I'm not going to make you do any like, yeah, say it louder or anything like that. Who here likes it when the speakers come up here and ask questions and expect the audience to like give answers, and then you're waiting for that other person to answer? Yeah, it's like that. Like, not early this early in the morning though. After PHP and MySQL, I didn't really know how to better title this. I think the title on the website's what you should learn after PHP and MySQL or something similar. It's all the same basic stuff. I'm assuming that you know PHP and MySQL here. That's all I assume that you know. We're going to be covering some stuff that you should learn after that, at least what I think you should learn after that. A couple things we're not going to talk about that you should probably still learn. We're not going to talk about security, mostly because you can fill an entire day with a talk like that and more. And if you were here yesterday, you should have seen Chris's talk. I'm sure it was really good. Considered looking at performance. They never considered statistics of what their application is doing. They never looked at message brokers. Some of them didn't even know what a message broker is, even though it might have solved some critical problems that they've had. And so this is sort of what I wish these developers could learn. What I wish that they could say, hey, you know, these are things that I should learn next after I've learned the basics PHP and MySQL. There's a couple rules in my talk. First one is we're all adults. We're all programmers here. And because we're all adults and we're all programmers, I'm completely aware that you're all intelligent people. I'm not going to bore you with simple details. For example, I'm not going to sit there when I talk about Xdebug, I'm not going to say, well, to install Xdebug, you're going to do PECL install Xdebug. I'm assuming you know how to read README files. I'm assuming you know how to read documentation. If you can Google this in a minute, I shouldn't explain it up here. You spent money on this. I don't want to bore you with the details. That being said, we are going to talk about the basics of rabbitmq and some caching, primarily because I think they're important. And especially for rabbitmq and message brokers, the concept is a little bit different from what people are used to. So we do spend a little bit of time there. The second rule is to ask questions. It ties into the third rule, but ask questions. If you're not sure of something, if something doesn't make sense, if something's not clear, ask questions. This is the first time I'm giving this entire talk in public. So there's bound to be some things that I've explained poorly or slides that aren't explained well. And so please ask questions that can only help you, help those around you, and more importantly, helping me, because that's all that really matters here today is what I do. The third rule is to learn. I want you to learn something here today. So it sort of does go back to that second rule, ask questions. Make sure you learn something. I want you to learn something. This is really me dumping what I know, what I think you should learn after PHP and MySQL. And so I'm hoping that you learn something here today. And if you don't, ask questions, because it's really important. So we're going to start with performance. You have to forgive me, I take medication. It causes dry mouth, very serious dry mouth. For a public speaker, this is really, really bad. So, performance. The worst thing you can do with performance is waiting until you get slashdotted. Actually, it's not slashdotted anymore, it's like reddited or something like that. You go down. That's not the time to be worrying about performance. You want to worry about performance from day one. You want to understand how your site is performant, how it will scale, and how to test whether or not it will scale. So what we're going to cover over the next short bit is we're going to find out where this performance is being impacted. We're going to look at various tools that you can use to narrow in on what really matters in your application. And we're also going to talk about load testing. We're going to talk about a bunch of things in between. But we're going to also talk about load testing. Who here has ever actually had to load test a website? All right. And who here, if someone asks you to load test a website, you default to like Apache Benchmark or Siege or something like that? All right. Well, that's good, because a lot of you are going to learn how to load test today. First of all, if we're going to talk about performance, I just want to get something out of the way. I don't know if these are still things that people talk about, but I know that I've still come across these conversations at local meetups and local user groups. These are things that aren't performance impacting. They may a little bit, but these things should not matter in your day-to-day. All right? Anyone ever hear or seen benchmarks on echo versus print? Or they might see for versus while benchmarks. People talking about static vars or object vars, which one is faster? You might have people complaining about methods versus functions, which one are faster? Objects are slow. Who here has ever heard that object-oriented programming is slow? All right. People complain that functions are slow. Functions are slow. You know how much all this really matters? In all honesty, in production, they're pretty much all worthless. I guarantee when you start checking for where your performance bottlenecks are, unless you're actually writing a benchmarking app that's benchmarking one of those things, your performance bottlenecks are never really going to be one of these things. It doesn't matter. Single quotes versus double quotes, it's not an issue anymore. And I know some of you have had that experience. Single quotes versus double quotes, it doesn't matter. In fact, yeah, I even say that right there. So what really matters? What really matters in performance? Well, this is from meetme.com. This is actually a New Relic chart. And it breaks down a single endpoint and where we spend time in that endpoint. Now, that endpoint right there does 90 milliseconds. So it's fairly fast-ish. It's fast, but it could be faster. The question is where do we spend most of our time? We spend most of our time in this purple region. If I were to ask people where that time is being spent, we might get different answers. The interesting thing here is that we spend, in that call, most of our time going out to Facebook's graph servers. This is actually a consumer for rabbitmq, which we'll talk about later. And so it doesn't matter as much in terms of user experience, but we spend so much time just going out to Facebook's graph servers that anything we do here, which we reach out to our internal servers, we do memcache increments, we reach out to feed, a subdomain on MeetMe, all those things sit right in there. Do you really think echo versus print is going to make any difference to that? With the Zen framework. That single quotes or double quotes are going to make any difference? No, not really. Other places that become an issue. So memcache. We use memcache. We use memcache a lot. And this is another call. This is actually a web call, an API endpoint. Right here, these are just memcache gets. This is taking over 200 milliseconds to get these, to go to memcache and get the data that we need. 200 milliseconds, that's a lot. I mean, when you think about it, who here has ever used memcache? Who here has ever thought of memcache as the bottleneck?
It's Mark.
All right. Memcache, the bottleneck, what? You're like, that's a thing that you turn on, and suddenly everything gets faster. You don't have to make database calls. Now, granted, in this case, we aren't using multigets. We aren't using multigets in this case, but multigets is using multiget in memcache means you're going out and getting multiple keys and getting all of them at once rather than one at a time. But even still, that's a lot of time that we're spending there. When you remove the memcache stuff, you see that the yellow band right here, that's just memcache increments. That might be for statting, for data. Memcache increments, they take up about, what is that, 10, 20 milliseconds just of increments. Now we're doing a lot of stuff on MeetMe. Each call does a lot, but still, you can see performance isn't always where it might be apparent. It's not always just in the database. It's not always, oh, well, it's in the algorithm that you're using. Oh, it's not in the networking. We have to look into why these performance problems are a problem. That being said, bad algorithms might be an issue. In performance, when you have bad algorithms, these are really noticeable. What we see here this is actually a banned words check. And the problem with this is that not only is the banned words check itself slow, which we're changing, but if you had a single user sending the same message to 5, 6, 7 users, the banned words check, the system that would run that would actually run the banned words check for each of those messages. Even though they're the same exact message, it would treat it as 6, 7 individual messages, and so it would rerun it every single time. And this would cause a major performance bottleneck for people that were sending out a message to multiple users. And of course, there's database calls. Now, database calls generally aren't this slow, but they can be performance impacting when there might be locks on the table or at certain times. This was an incredibly bad API call right here. And that's all database right there. It's all waiting on the database. Of course, we have all these external resources right here. It could just be that your PHP is doing a lot. This is one single call. This is one of the previous calls, but this is what the cachegrind report in qcachegrind, I believe is the application name. This is the graphic representation of the amount of time spent in each of the different functions in each of the different areas. And you can see it's just doing a lot. There's a couple big ones right here, but there's still a whole lot of small little things that are happening. And these big things aren't easy to replace. They do a lot of fundamental core stuff. So we've started looking into it. Another thing you should be aware of in terms of performance are these numbers right here. Who's ever seen this? You can literally Google for latency numbers every programmer should know. And these are really important. This is the human readable version. I generally like this because reading, like for example, you can see reading 1 megabyte from SSD, sequentially, mind you, takes 1 millisecond. And that's still, when you think about the amount of data that you could be sending, that's still a lot of extra time. Sending 2K bytes over a 1 gig network. If you send over, I think I did the math, I think if you send over 2 megs of data over your internal network, it's going to cost you about 10 milliseconds. And if you end up caching that in memcache, if you end up caching that large amount of data, so if you cache your entire web page with all this data and you send that over, it's going to cost you time. And so you have to be aware of this. You have to be aware that all of this, all these little things are going to add up. So I know a bunch of you are probably asking right now, what does this really mean? What is this? I'm telling you about all these performance bottlenecks, and what does this really mean? And the question is what do all these things that I just showed you have in common? Not looking for answers, you don't have to answer. But I know one of you out there would be like, well, Jason, they all have charts. You just showed me a bunch of pretty pictures. They all have charts. And my response to that would be exactly this. Exactamundo, my friend. And not just charts, but reports and data. You see, when you're dealing with performance, you can't just say, well, that looks like it's going to be slow. You have to have performance data. You have to have charts. You have to know what is going on inside your application. And we're going to talk about things that you should be monitoring in your application. How many of you already chart out everything you could possibly think of in your applications that you build today? How many of you chart out some of the things you think about? If I asked you what the 95th percentile of the response time for your average user accessing your website, would you be able to tell me? Honestly, I wouldn't know. For me, I'd have to figure out which section it was, and then I'd have to look up the data. So, brings up two nice rules. What gets measured gets managed, and you can't improve what you can't measure. So, if you want to do anything with performance, you first have to measure it. Should be the first key takeaway you take from this. If you want to measure, if you want to improve performance on something, you have to be measuring it. And you can't just start measuring it the day of and then say, oh, we had this improve. You want to look at it week over week. You want to see if this is a trend. You want to see if little things that you do here impact things in other places. I can't count the number of times that we've sat there, released new code on a Thursday, and then looking at stats and something else moves. And we have no idea why, but we know that it moves because we've been monitoring it, and then we can trace this route about how touching something over here impacts something over there. So, the next question is, what should you be looking at? What metrics, what stats should you be focusing on? These are called KPIs, or key performance indicators. I actually don't ever really use those words in real life, but that's what I see in professional people's things, so I put that up there. So, some things that are important. Availability. Availability is obvious. Availability is obvious. That's the 99.85% uptime. That's the 53 minutes of downtime that you might have had last month, right? You want to have good uptime. That's an obvious indicator of whether your system's working. Latency, that's another fairly obvious one. If your site is slow, if people take forever to reach the site, they say, what was it, if you shave 100 milliseconds off either way, it decreases, or it decreases the amount of profit a site makes or something. I don't know the exact numbers, but I know that you should know those numbers for your own site or whatever system that you're building. Critical bug count and resolution. How often are critical bugs being found and resolved? That's another KPI. Should give you some indication of the health of your system. If you're finding more and more critical bugs as time goes on, that might be an indication of something. Maybe you've been releasing things that are more buggy as the process for releasing changed. Back-end server stability. You can easily have a site that on the front end, to the user experience, to the user, they see nothing wrong with the site. Or they might see a little bit of delay, but they don't really notice it. But maybe your back end is suffering. So now your DevOps guys are getting paged at 2 a.m. in the morning because they're having to restart things, and the only reason your site is still up is because they're able to swap inboxes fast enough. So don't ignore the back end stability. User retention. This may not seem obvious, but are users coming back to your site? You may say, well, that has nothing to do with programming, but it has everything to do with what we're building. If what we're building isn't retaining users, we need to know why. Is there some reason that users are suddenly not coming back to the site? That's something that's not apparent. Maybe it has nothing to do with availability or latency or any sort of critical bugs that we can obviously see. Maybe it's the fact that we changed the color of our buttons and moved them down below the fold and now people can't see them or they don't realize it's there or some other simple thing. You also have your own key performance indicators. For example, at MeetMe, we have a messaging platform. And one of the things that we look at are the number of chats started that reach 3 replies. So if someone sends a message and we do 3 replies back and forth, that's something that we consider to be good. If that goes up, we want to know why that goes up. Is it something we planned or is it something we didn't plan? If that goes down, we also want to know. Is there some reason why it went down? These are all examples of things that you might want to look at. And I'm sure in your own business, in what you're doing yourself, you can come up with additional things that matter to your business, that matter to your company, that matter to whatever project that you're working on. And something you'll notice is that these KPIs are not just technical, they're also business related. So, how do we actually collect these stats? How do we get these stats and put them to use for us? To start with, who's ever heard of StatsD? So StatsD was written by Etsy, which was inspired by a project by Flickr, but it's really written by Etsy. It can be run locally. It uses UDP, and the nice thing is that it sends data to other services. This is a really brief explanation of what statsd is, but these are the essential key points. The thing with statsd is that it takes the data that it collects that data that you want to store, and it sends it over to Graphite. So for example, let's say you have your traditional PHP application and you have a server where you store all your stats. Maybe this is Memcache, maybe this is Redis, maybe this is a third-party service that you're sending stats out to. So traditionally, your PHP app might sit there and just send it directly to the stats server inline. And so what this means is that during the course of actually processing the application for the user, you're going to send these stats out. You might collect these stats and at the end of the request then send it out all at once. But the point is that you're directly sending the data to the stats server. And again, whether that's Redis or Memcache, however fast it might seem, you're still doing this. The way I recommend setting up statsd is that you set it up to sit on the same web server where your PHP application is. So it's literally sitting in the same virtual environment or the same box. And what you do is you have the PHP app write to statsd, and statsd will handle writing out to the stats server. And this means your PHP application doesn't need to make additional network connections just to record stats, because the last thing you want to have happen is your site be negatively impacted because you're just collecting a few more stats.
This directory called config, so you notice that you actually.
It's another service that I recommend you look into. It's called New Relic. New Relic is free for certain parts and paid. It's not cheap, but if you can afford it, I highly recommend it. I love New Relic and all that they do. It's an amazing product. There are lots of detailed information on transaction. It provides alerting. It's very easy to set up. It has a similar model to statsd in the sense that it has a daemon sitting on the server, collecting the stats, and then publishing those stats to New Relic. And there are lots of different libraries available to you on Packagist through Composer. There are packages, I believe, for Laravel, Silex, Symfony, Cake, Lithium, and probably more. So if you use any of those, you could probably plug it in. But they also have their own library that you can plug in if you're using your own framework. So to give you an example of some of the things that New Relic provides. So this is so I had to be careful about what I showed. We're a public company. So this is an actual report from one of our endpoints. And we can see here, this is the mobile messages folder. Memcache get takes up this much portion, this much of the request. It's a really slow request. We can see there's database calls right here, right up there. Another database call over here. We can also see that we also make a call back to our rabbitmq load balancer, and these are all taking up time. You see the number of requests per minute. And it also digs down into where we're spending most of our time. This is more detailed information on specific transactions. So this is a specific individual transaction that had occurred at a certain time. And what it does is it looks for transactions that are exceptionally slow so you can pinpoint where the problems are. In this case, it's a problem with the Redis connection, with Redis, our connection to Redis. And most likely because it's got the count of 2, this means that what it did was it connected, it failed to connect, waited a bit, and then tried to reconnect. This is definitely a problem that we're trying to solve right now. We've been able to pinpoint down that Redis connections are an issue here. And this just highlights it. It also provides you with information like this, breakdowns of the actual call stack. So you can see where it starts and all the different things that we go through, and it gives you the timings on everything and how much of a duration it takes up. It provides really in-depth reporting for these different transactions. And of course, it also can find errors. For example, it found these errors right here. And so for example, right here, this was probably on a deployment. For some reason, messages got changed, and maybe at the right or the wrong time, things were trying to look for it. And because it was being deployed that way, it couldn't be found. And we'd have to look into that. But it only happened a few times, so that's not bad. Another system that you can use is XHProf. XHProf was released by Facebook. It's meant to be a PHP profiler. The intent is that you can run it on production servers. There are problems with that. I would highly suggest that you don't just necessarily run it on production servers. Maybe run it on one production server, enable it when you need it. I haven't used it recently, so I don't know how it works in the latest PHP, but I do know some nice things about it. When I did use it, it can profile blocks of code. So if you want to look at a specific block of code rather than all the code, you can easily do that. And you can also easily diff between the two runs. There's a GUI that's available, a UI that's available that you can go ahead and use that to review. Xdebug. Who here's ever used Xdebug? Who here's ever used Xdebug's profiler? It's really nice. So Xdebug you should all use for debugging, but the profiler is what I really love. One, don't run it in production. Do not run it in production. Don't run it in production. Not only security problems, but there's also performance issues about running Xdebug, enabling it in production. Enabling Xdebug is fairly simple for the profiling. There's multiple ways you can do it. The easiest thing for development is just profiler enable one in the ini file. That will profile every single request to your PHP application. You can also use profile enable trigger and then use a get or post param or something, set something in your cookie, and only then will it profile the actual application. There's the other part right here is profiler output name. I highly suggest changing this from the default, which I think is cachegrind, and changing it to callgrind.out. And the reason why I say change it to callgrind specifically is because the tool that we're going to use to view this, that I'm going to show you to use, the GUI, it by default looks for something that says callgrind at the beginning. It just makes it easier when searching for the files.
And then you can just
So an example of this running. So I'm going to run a script that this is my live demo, by the way. I pre-record all of them. Never any technical difficulties here. So we're going to go ahead and I'm going to show you a script that runs, and then we're going to look at the Xdebug profile of that. So we're going to run this simple script. We'll see what the script does later. So we've run it once, and I actually run it again, and I get two different things. And we're going to go ahead and explore it in cachegrind, in this. So you can see it gives you the stack trace, the blocks of where it's spending its time. You can double click and click into and see where they're spending our time. This is not actually doing that much. Gives you the source code that's being called. It's a really useful tool. If you've never used this, you can really dig in and see exactly what's going on in your application. This is the second call. I did this call 2 times. This is the second call. You'll notice that the graph looks completely different. We'll go back to that in a second. But again, there's all these different options here, and it allows you to view your data in so many different ways. And the more complex the application, the more data is going to be available. So this was the first run of that script, and you'll see where it's spending its time. You can see how much time it's spending. And just by looking at the graph, you can see, like, oh, this is taking up some time, but this is also taking up a lot of time, and just seeing how everything's laid out. When we actually go to the second run of that same exact script, and we run the script once, then a few seconds later I ran it again. When we ran it again, what you see is a completely different layout. And a lot of this is because we're using cache in the background. And this is an important thing to note. You need to not only profile your applications, but you need to understand the state of the applications when you profile it. If you are profiling an application when it just starts up, it hasn't had a chance to get anything into cache, it's going to have a different look than if you profile something that's been running for an hour. And so when we start talking about load testing in a bit, that's one of the things that I'm going to suggest. That you do smaller load tests, but your final load tests are going to be running for hours and hours and hours. Because you're going to get a different look. You're going to get a different visual of what your application is actually doing in the long term. Another tool to help you collect stats is Graphite. This I recommend being the endpoint for where all your stats sit. So PHP sends to statsd, statsd would send to Graphite. Graphite can take in data from statsd. It makes beautiful charts, easy to use charts. It has a lot of statistical operations that can be done. I believe it does the standard deviation, or like Holtz-Winter, I believe is the name, and a bunch of other different operations that it can perform on it besides just doing nice little charts. And there's a whole bunch of libraries and packages there as well. This is a sample chart. So this is our chart from our rabbitmq3 cluster. This is our node 2 box. And this is the memory that the node is using. And you can see it's pretty steady, the amount of memory that it uses. And then right around 9:30, it spikes the amount of memory that this node is using. We actually know why that is. It's our daily re-engagement emails that go out right at this time. It starts and kicks off. So this is a natural pattern that occurs normally. But it's still important to know that, hey, I see how much memory it's actually using, because it looks normal and then bam, it jumps up. Well, we want to know, we want to be able to account for that memory usage. Here's another chart in Graphite. These are more performance checks on our RabbitMQ, on our consumer clusters, on our consumer boxes. We can see the amount of CPU idle that's available on these boxes. And so, for example, up here, under our Jack consumers, we see a steady natural trend. Nighttime, it increases of CPU idleness. MQ consumers, the same thing. We generally try to start spreading the load when we hit 70, 60% idle. We always want to be able to easily double the number of consumers that are running, or their CPU usage, to account for any spikes. Over here, we see under rejected, which is a Python consumer framework, it starts to spike. And what we'll note is that it also happens around 9:30, and that's because rejected handles most of our emails. So right around here, these rejected consumers start to peg the CPU, and they just use so much CPU trying to send those emails out. And so having a clear understanding of why this might be happening, going back to the previous chart and seeing the memory usage also happening around that same time, can easily tell us exactly why we might see certain spikes. And all this goes back to data and how you visualize that data. So I highly suggest you look into Graphite for your data needs. So the way this would be set up, simple. You'd have your PHP app with statsd on the same box, and statsd communicating through UDP over to Graphite. The nice thing about having Graphite sit there is that you don't have to have just the PHP app and statsd sending to Graphite. You can also have other services as well. So for example, if you have cron jobs that are running, you can go ahead and actually have that cron send data directly to Graphite, or other back-end services. For example, that memory check that I showed you. That memory check was actually written in Node.js and just goes to the RabbitMQ API and collects the memory information and then sends it right off to Graphite. There's no intermediary. And so that's nice. You can dump all your stats into this one system. The other nice thing about Graphite is that it really allows you to have a cluster of Graphite servers. So you don't have to have just one Graphite box. You can have multiple Graphite boxes as well. I love this quote. Weeks of programming can save hours of planning. I love that. My friend, my colleague Eric Weaver found that on the internet and posted that. Who here uses cron for something? So I'm not going to talk about it much, but I just do want to make a mention. Look at Rundeck. Rundeck is sort of a better cron. It's a nice open source tool that allows you to essentially do what cron does, but in a more controlled, managed environment. It's like having those cron files that sit there and you may forget that this cron file is running there, and you create a new box and you don't copy the cron file over and then don't set up the cron jobs on this new box, and then you suddenly lose this cron. Rundeck is really there for managing that sort of thing. I highly suggest you take a look at that. It is a better cron. It does some nice things. So now we're going to talk about load testing tools. So at the beginning, I asked who's done load testing, and people who've used Apache Benchmark, people who might have used Siege. We're going to briefly talk about each one of these, and we're going to spend some time with Redline, because it's my favorite of all the tools. So before we start getting into the load testing tools, though, I remember the first time I was asked to do a load test. I really didn't know how to do a load test properly. All I knew was Apache Benchmark, because that's what everyone said. Oh, just use Apache Benchmark, hit the API endpoint. Boss was like, dude, you need to do a load test of the website. All right, cool, I'll do that. I go back to my desk. I have no idea, and I talked to one of my colleagues, and then he's like, dude, just relax. Just relax. I didn't know what to look for. I mean, all I knew is you send Apache Benchmark at a URL, and then if it crashes, yay. If it crashes, okay, no. If it doesn't crash, yay. That's it. That was all I knew. Before you start load testing, there's a bunch of things that you need to know. Again, this goes back to all the stuff we've been talking about already. Stats, knowing data. You need to know what it is you're monitoring. You need to know what it is you're after. So there are certain questions that have to be asked before you ever start load testing. So you go to your boss, your manager, whoever you need to go to, and you ask them some simple questions. For example, what is our anticipated average number of normal users under normal load? That should be obvious, but you should also understand what your normal load is. What do they consider to be normal load? It's not the average. The average might account for severe downtime. What do they consider to be normal load? That's the important thing. Then you need to know at peak what the average number of users are. When you hit that peak amount, what are the number of users that you need to account for? You also need to know where you're going to be running your load test. You essentially have two ways you could do this. One, you could do it on production during time when it's not peak. It's a very valid way to go ahead and do a basic load test. However, I'd highly recommend that you go ahead and you set up a replica production environment. Now, this is going to be easier when you are in the cloud, because if you're in AWS, you simply press a button and boom, you have a copy of whatever your production environment is, and you can go ahead and test there. If you're using actual hardware, it's going to be a little bit more expensive to just simply say, hey, can we buy a second set of everything that we've already spent on for production just so I can run some tests? That being said, I still think it's worthwhile, if you're running on actual hardware, to go ahead and set up a production environment in a cloud service and get similar numbers for your hardware and see what you can come up with. That being said, you still need to know where you're going to run your load test. The best thing you could possibly do is run it on the production servers that you're actually going to be deploying with before the site actually goes out the door. You also need to know, there we go. You also need to know the state, if your application actually has state. And this is important because that state can change. Remember how we talked about before how certain things changing in the underlying side of that application changes how the actual application runs, changes the performance of that application? You need to understand this. And finally, you need to know what the intended goal of the load test is. My preferred goal of any load test is to break the system. I want to build a load test that will crash the server. Last year, I was on the load testing team for 4 standalone apps. I didn't build the apps, but I got to break them. And let me tell you, there's so much joy in being able to build a simple little script that can tear down 3 months of somebody's work and be like, well, I just crashed it from my desktop. Go fix it. It's just so much joy in doing that. The other thing you can try to achieve, rather than just breaking the entire site, is actually seeing if it can withstand the numbers that you're expecting. Now, you might be asking, why would you want to break an application? Why would you want to push it beyond the limits that it was designed for? Well, you need to know what the bottleneck is. You need to know where it falls down first. And when it falls down at that point, you then have a way to say, well, Redis was the bottleneck. How are we going to solve this? Do we need this now? No. But we can start thinking about it now. We can start making sure that the application is designed, or the changes that'll make it performant are going to be put into it before we actually need it. I highly suggest breaking some of your own applications with a load test and seeing where it falls. It's a lot of fun. And you get to see how you can actually scale out. Also, I don't recommend actually asking a boss any of this stuff, especially if he's sitting at a desk, because they're probably not going to know all the answers. So, our load testing questions. So these are the load testing questions that we just asked. These are some of the key things that you want to be able to answer before you start load testing. In addition to having all the metrics, having all the stats, having your key performance indicators already present, things that you can already look at. None of these talk about improving messages being sent. However, when you do your load test, you want to make sure that that key performance indicator moves in the right direction, or at least doesn't get worse. One thing that's not up here, and one thing that I don't have a slide for, I want to make sure I mention, is when you're actually running your load test, make sure you actually use the application. Either you or preferably someone involved in QA. The person spending most of the time working with that application should be the one sitting there using it while it's under load. And the reason why is all the numbers in the world don't mean anything if, while actually using the app, he goes, well, you know, it stutters a bit. It's starting to stutter. We actually saw that in an app. It worked beautifully in any sort of test environment that was set up. But once we put it under load, we noticed that scrolling on the app would freeze. And that was because they were doing the remote request to the API server on the same thread as the UI. Obviously bad, and they just missed that part in the application design. But we only caught it because we were using it under load. And so we went back, we made a debug report, and they fixed it shortly thereafter. So it's not just stuff on the server side that's going to make your application look bad. It's stuff on the client side as well that can easily do that. We've all been in that situation where we've looked at a program and we go, oh my gosh, this program is horrible. It's freezing up all the time. But whether it's on the client side or the network side or the database side or the server side doesn't really matter to us. All that matters is that the end result is that it's not responsive. So make sure you're actually testing out the application that you are load testing. So now we're going to talk about actually running load tests. So, Apache benchmark, we've all seen this. For those of you who haven't, Apache benchmark, basically you give it a URL, you pass it the number of requests and the number of concurrent requests, and you point it at this URL, and it goes off and does what it does. It hits that URL, and it spits out a report. Pretty basic. Siege has some additional options. I'm not going to get into it here. You can read the README or the help file. But basically, it has the same thing. You can add a URL list to it, too, if you wanted to. Hits URLs randomly if you patch a -i in there. You could use these. It's great for basic API endpoints. You want to test out your basic website. It doesn't have a lot of, it's not an API. Maybe it's just a WordPress site and you want to see what it can handle. And that's great for that. It's static content being displayed and things of that nature. These are really efficient for that. There's another more complex tool. A colleague of mine recommended I share this, JMeter. I've never used it personally, but I know people that I worked with have recommended that we look into, that they've used this in the past, and they've recommended it. Because I prefer Redline, I never explored it too much, but it is an option if you wanted to explore it. It is free. Locust.io is sort of the open source version of Redline. It allows you to run lots of little clients on little servers attacking an endpoint. The nice thing about it is that it's scriptable. Now, it's scriptable in Python, so you have to know Python, you have to use Python to script it, but you can script it to do whatever you want, which is really nice. And so Locust.io is out there. Of course, the one I recommend is Redline 13. As it says, it's almost free load testing in the cloud. It uses AWS. It's fairly cheap. It is paid for, but it's fairly cheap. You get really good load testing for really low costs. I just run it all the time whenever I want to load test something. It doesn't cost that much. We're talking pennies for the amount of time that you'll be load testing. The nice thing about Redline, it does have the option for a simple URL support. So you can just put in a URL and have it hit that endpoint. But the real power comes in its ability to do custom scripting. And it supports custom scripts in both PHP and Node.js. We're going to look at a custom script written in PHP for load testing shortly. The thing about the PHP script is that it needs to be a single PHP file. It has to be named custom test, and it must extend a Redline 13 class called load testing test.
Mute that.
Node.js has a little bit more power in that you only have to export a specific function, but the nice thing is that you can do it does an npm install before it runs. You upload a tar file, it opens that up, runs an npm install, and then runs the test. So you get all that power. With the PHP file, you just get what's in the default PHP stack, which I believe is PHP 5.3. But it does have enough PHP that you can do essentially anything you'd want to do in a load test. So, to show you a cut-up example of what a load test would look like. So, obviously this is our class custom test, extending load testing test. And it's going to pass in a couple pieces of information here. Oh, go back one. It's going to pass, Redline is going to pass in the test number, which is literally the number of the test. So if you do 1,000 users, 1,000 tests, it's going to pass in 1 to 1,000. The random is a random number they pass in. And the resource URL is not really used for your custom test. I believe it's used for their standard default test with just the URL. To go over exactly what this test is doing, just so you can see the power of what a custom load test can do. Right here, you see that we take the test number and we're going to set that to be the charm user ID. Charm is the application we're testing here. Beforehand, we set it up so that way we have we had a set of user IDs and then we could pass those in for load testing. And so all I'd have to do is I could take whatever user ID was passed in here and I would know it would work. So this is just mimicking a real charm user ID. But we're going to use this for all future requests. The other thing to take note of is that we actually go out and we get a video file from an external source, since they spin up the AWS instances on request. It doesn't have any data besides the file that we actually upload. And so what we do is, before it starts to run the test, it actually goes out to an S3 file, grabs a short video, and relocates it locally. And it does some magic under the hood to make sure we're not doing 20,000 different videos for each of the things that are running on each of the load tests that are running on the same box. But what we're going to do with this video is we're going to upload this video in our load test. We're going to upload an actual video in our load test. And the reason why we want to do that is we want to load test the application server's ability to handle video uploads, to handle actual file uploads. When Redline runs, it's expecting there to be a method called start test. So you have the custom class name, custom load test, and then in it, it's going to look for a public function called start test. And this is where we actually run all the different tests. This is how we plan everything out. Now, there's a bunch of functions that I built, run test X times. The whole idea behind setting it up like this was to easily allow us to change the order or to modify what we're testing at any point. One thing I wanted to make sure of when we were load testing was that if we load test one thing and after 10 minutes we go, okay, well, let's try it a little differently. Let's adjust the numbers a little bit differently. We can go ahead and quickly and easily do that. I could easily make sure that we're testing file upload more often just by repeating that line. Yeah, it's a little bit of copy and paste and stuff like that, but it works. It gets things done. And when you're in a room with 4 other people doing this load test, you want to make sure that you can make these modifications quick and easy. So to start off with, in our load test, we're going to run a test login. And this test login is actually a function in the class. And some things to keep in mind. First of all, the method name we're also using for the reporting. So in the end report that we get from Redline, we can actually see that this, whatever method name that we're using here, is going to take X amount of time to run.
Say like user.
We also mimic the time in between requests that users make. So we check to see if the sleep is passed in as an integer, we should sleep that long. If it's passed in as an array, we do a random. So we can say array 1, 10, and so it'll do an empty rand 1 to 10 and sleep that amount, sort of randomness to it. And if nothing is passed in but sleep is true, we're going to go ahead and just default to 2 and 4. We want to simulate sort of real user experience. And the way we try to simulate real user experience, how we come up with the order of things, how we come up with the length of time people spend on certain things, a lot of that is driven by QA, or the people that are testing the app, that are actually using the app or the application. And they come back and they say, well, we expect that users will be spending, this is going to be their path through the app. This is the intended path through the app. We had one app that was launched called Choosy, and it had a real-time messaging functionality built into it, and we wanted to test that real-time messaging. And so we built a load test with real-time messaging built into it. It would actually, the load test would load up, do 2 connections to the server in that one script, and then have 2 users chatting back and forth. What we wanted to do was make sure that 20% of the users could be chatting, while 80% of the users could actually be using the app. That was our goal. So what we did was, instead of running 1,000 concurrent users, we ran 800 concurrent users using the load testing plan for the application, and 200 users just for chat. And a lot of that was driven by product and by QA saying, these are our goals. Sure, I already covered what these do. The key thing here is at the end of all this, we call out to the actual test. In this case, we're going to do the test login, and we're going to get the response right there. That response determines whether or not we have success or failure. If we fail, we're going to record this error. Now, this record error function is provided to us by Redline 13. This allows us to see any errors that occur in our load tests. So we record the error, we simply write out the error message, and we move on. Otherwise, we're going to go ahead and record the time in between the requests, and we're going to simply record the URL page load time and record the page time as a whole. It tries to give both the individual page time, and response times as a whole. And so we report both of those. I forget I have these nice little things. So that's test login. What does test login actually look like? So right here, we do a call out to login user ID. And login user ID looks like this. And so all we're doing here is we're doing a curl call out with some basic information to do a login. We set up just for load testing a fake login to simulate login with the user ID for both the username and password pairing. And we send that over, and we get the response back. And the important thing here is that once we get the response back, we get a return token, we get the auth token, and we return that auth token. And so this is login user ID. We get the auth token back. This auth token is required for the rest of the API calls that we're going to make. And so, of course, we get that auth token, we set it to the class, and then all future tests have access to this auth token when running. And right here, we simply say, did the curl request return successfully? Return that result, and that comes back to this right here. That result, whether or not it was successful or not, gets recorded here. For our test, we also set up something called run test X times, because I'm lazy and I don't want to put in loops everywhere. So I literally just put in the name of the test, run it 20 times, have an average sleep between 4 and 8 seconds, and don't record this. Don't record this in Redline. And so this is run test X times. That's all it is. It's just a simple loop. Now from here, you can see test file uploading. We're going to run this 20 times. Test file uploading allows us to also input more run tests. Test file uploading won't get reported, but these will report test queue generation, test get queue, and test file upload. And test queue generation is right there, and that's also test save filter and test get queue. These are all custom functions. A lot of these things are built on top of the API that we're testing. And what I really want to show you is the power that you can do when you're running custom load tests, beyond just hitting an API endpoint. If you've never had a chance to sit there and script out a load test like that, I highly suggest you do it. Actually script out a user. When I was doing that, the first thing I would do, and I'll show you this in a bit how it was done, the first thing I would do is I would run the load tests from my laptop, and I would get sheer joy when I could bring a server to its knees, a new application that was being built just from my laptop. And we're not even talking about the MacBook Pro Retina. We're talking about the old 2011 MacBook Air. Just bringing servers to their knees with that. That's a lot of fun. The custom the functions that Redline provides, I mocked out. And the reason why I mocked these out is because I wanted to run them from my laptop. You're only going to ever upload that single file to Redline. But you can go ahead, you still want to be able to test out your application. So record page time. Whoop. So record page time, records the page time, URL page load. If we wanted to, we would record the download size if this is important, and recording errors. These are all mocked out. And for my case, I wanted to see them as I'm running them on my laptop and to see what kind of responses I was getting. So I mocked a lot of this stuff out just to make it easy. I also went ahead and abstracted out, created their class. I think they provide this now, but at the time they didn't. But this is the abstracted class. So that way I can extend it like I should and still be able to run it. It doesn't do anything because I'm not using any of this stuff. But you'll notice here, you can actually hit an endpoint and you can tell it to load all the resources. So it'll go out and find the JavaScript files, the CSS files, the image files, and it will do things for you. Redline also provides an interface, a library that will allow you to fill in forms on your web page and submit those forms if you want. And it'll do a lot of that stuff for you. We were testing an API, and I do most of my time is spent testing APIs. And so I don't use a lot of those functions, those features. To run the Redline script locally, I simply included the config file, which includes both the functions file and the custom test file. And then I just run start test. I pass in some basic fake information right here and just run it. And then when I wanted to run a whole bunch of tests all at once, I wrote a simple bash script. And basically what this bash script does is it allows me to say, run whatever load test script I want with this many instances. So I would say, run this load test to simulate 40 users. And it would just go ahead and background 40 processes and run that. And that would be enough to choke some of the servers first go. Again, the goal of this was to test our load testing scripts locally first. And it is a lot of fun when you can take down an API that someone has just spent 3 months building just from your laptop. So it's time for a break. We're going to be talking about caching next. So I guess about 15 minutes, and then we'll get started again. If you have any questions, by all means, come up and ask. Caching. When I wanted to talk about caching, I wasn't really sure. I was like, can I really fit in a good portion of this talk and talk about caching? Especially since it seems like caching is really something simple. You do a check cache. If it's not in cache, you got to the database, and then you cache the results, and then you return the results from the function call. And that's pretty much a lot of people's idea of caching. That's where it starts and ends. It might even be just flipping a switch on inside of a framework or something that says enable caching, and caching is magically enabled. But we're going to talk about caching. I love caching because it allows me to talk about my favorite quote. Who's here? Have you ever heard this? There are two hard things in computer science: cache invalidation, naming things, and off by one errors. I love caching. So caching allows for speedy access to data, right? That's essentially what it is. You have data that otherwise would take forever to access, forever in the computer world, and you're going to put it in an area that's much more easily accessible. Who here uses memcache? I just want to get a raise of hands. Who here uses APC or APCU for user-side caching? Who here thinks it would be weird to use both memcache and APCU? I know you're thinking, he's asking that question, so obviously it's not. We're going to talk about that. We're going to talk about a couple things to start with. We're going to talk about cache location. We're going to talk about how to think about cache and where its location. We're going to talk about planning cache usage. We're going to talk about how to use different cache for different reasons. We're going to talk a little bit about updating cache sanely. We're going to focus primarily on APCU and memcache. But the important thing, like in most everything that we're talking about today, is that it doesn't really, APCU and memcache aren't critical. You can use whatever caching, local caching you want, or any external cache that you want. And the lessons that you learn here today are going to carry over to that as well. I tried to structure the talk in such a way that it's not PHP-centric. So just because we're talking about PHP, APCU, and memcache doesn't mean it's only useful for PHP, APCU, and memcache. So, cache location. What do we mean by that? Well, this is what we call local cache. Here you have a server, and you have the client, a web server, whatever application you're running, and local to this is cache. Here's some cache that's directly tied to that client. And then that client is talking to a server out here. Maybe the database server, maybe it's Redis, maybe it's some other system. This cache might be a local cache inside the code. This cache might be considered APCU. It's not what it is that matters. It's the relationship, where it is in relation to everything else. Then you have something called external cache. This cache sits externally to everything else. It's going to sit externally to the client, and it's going to sit externally to the server. This is generally going to be something like your memcache, or if you're using Redis as a cache, it might be Redis. This is an external cache. And finally, you have a cache that sits on the opposite end, a remote cache, a third-party cache. This could be your database's cache, its internal cache structure. This could be a third-party API, and this third-party API could have its own cache. The important thing is that your client has no direct influence on that cache. It has more influence on the cache here, but so do third parties. The client here, for local cache, has a lot of influence on that cache. And so we have cache sitting in 3 different places. And this is important to think about when you're dealing with deciding where to cache your data. Because if you think of cache as just one thing, okay, we're just going to cache the data and that's it, you're really missing out on optimizations. Because at each single point, you can optimize for different levels. The client may not have control over this, but you do. You might have control over this. This could be the caching on your database, and you might be able to set the database cache to be a lot larger so it can cache a lot more information. So it's best when thinking about cache, not just to think about cache as one thing, but about where it's located as well, which is also important. So, as I mentioned, our local cache could be considered something like APC. Our external cache would be considered something like memcache. And our remote cache might be something like RAM on the remote server. The cache being stored in RAM. There's other things too. So you could also have in-code cache, which we'll get to. You could also cache things in your code itself. For memcache as well. And with memcache sitting there, you can have this sit as you can have over here on the remote side have an internal API that caches things as well. Now here's the thing, when you're thinking about local, external, remote, it's not just this. It's all relative. For example, this server could have a connection out to here. And so this server would have its own local cache, and this would be a remote cache that it has access to. And so you may have several layers of cache before you ever get up to your client side, the client side over here. This could be right up here. This could be your JavaScript application. This could be something written in Backbone well, I forget all the other names, but Backbone. And then right here, this could be the browser's cache. And this could be the underlying API endpoints that we might be making JSON calls to. This might, again, be memcache. This could be, we could consider this APC. If this had internal localized cache to the code, this right here could be considered APC. And it's important to understand this. It's important to understand where your cache lies and where you're going to place this cache. So, we have local cache, we have external cache, and we have remote cache. I think it's useful in talking about cache to start off by building our own cache, our own internal in-code cache. So we're going to take a look at a bit of code. Now this is mostly set up for example purposes. We're going to have this member class right here. And imagine right here we're actually going out and going to the database and we're getting the member information. All right? So in the constructor we're actually getting this. And we have this factory function right here which allows us to get a member, and we pass in the member ID. And what we do is we're going to store this member ID in store the member in a member list array. All right? And what we do is we check this member list array, and we check to see if this is set. So if this member ID is in the member list array, we're going to return the member ID without actually going out to the database and getting this. We're simply going to return the member from our internally local code cache. And we'll get to other reasons why you may not want to do this later, but For right now, this is what we're doing. We're building our own internal cache. If it doesn't find it there, if it doesn't find it in the member list, we're going to go ahead, we're going to go out, we're going to say new member, member ID. Up here, it would go out to the database. It would return the object. We'd store it in the member list, member ID, and then we'd return the member. And now, the next time we requested this member ID, it would find it in the member list, and then it would return it right away. So we don't have to go out to cache again. In this case, in this example, this is our local cache. And memcache, let's say we're going out to memcache here. Memcache might be our external cache. Memcache can be our external cache, and then the database might be our remote cache. We're not even using APC. We might be using APC at other points, but we'll get to that. So we're going to run a little sample here. We're going to take a look and see what happens when we run this. We're going to pass in get member 1, get member 1, get member 1, and then get member 2. We're going to see this running. And what we'll see here is that the first time it uses an uncached member. The second time, it's going to use the cache member because it's already stored locally. The third time, it's still going to use that cache member because, again, it's stored locally. And then the fourth time, we're using the uncached since we haven't called it for member 2 yet. And that's using our local cache. Now, there's a problem doing it this way. I mean, this is really nice if you're doing a simple web request and it fires once, and let's say you're calling member out in a lot of different places, and you go out and you get that member information once, and then another service might need that member information, so it doesn't have to go out to any external resource to get the member. It has it stored internally right here. So it makes it really quick and easy. It's already in memory. You don't need to requery it in any way. But there's a problem. There's a potential problem, I should say. And that is that the member list can grow really large. If we have this in a long-running process, and we'll get to long-running processes in PHP later when we talk about rabbitmq, but if we have this sitting here and constantly we're adding new members to this member list array, it's going to continue to grow, and we're going to eventually use too much memory, and we're going to crash the system. The other problem is that we could have data that is no longer valid, but we'll get to that in a little bit. So when talking about cache, we need to talk about cache invalidation. And so we're going to talk about these different solutions, specifically these 3 solutions. We're going to talk about least recently used, we're going to talk about least frequently used, and we're also talk about something called adaptive replacement cache, or ARC. So LRU, basically it's a very simple algorithm. It simply says it keeps everything in a queue. And so the thing at the beginning of the queue, the thing that was first placed there, is going to be the first thing that gets removed. That's all it really cares about. Now, it will reorder that queue. If it gets accessed again, it'll move it to the top because it was more recently used. But at the end of the day, what it's doing is it's saying, oh, you haven't been used in the last 10 milliseconds or 30 milliseconds or 2 minutes, however long it is. We're going to go ahead and remove you from the queue. We're going to remove you from cache. And this would be used, in our case, for example, if we want to limit our member list to 100 members. So that way, once we hit 100 members, we go to add 101. Well, now we're going to go ahead and remove the first guy, and we're going to put the 101 on top. And now still it's only 100. And anytime we access somebody, we move them to the top as well. So also least frequently used. This does a little bit more work. It keeps track of the number of accesses to an item in cache. So what it'll do is it decides that, okay, you've been accessed 5 times, but maybe you haven't been accessed in the past 5 minutes. But you have the most accesses of everybody, so we're going to keep you around. You, however, have only accessed once. Now, you may have been accessed 10 milliseconds ago, but we're still going to get rid of you because everyone else has had more accesses to you in cache. And this is really handy for things like data based on popularity. Then we have probably the most complicated one, which is adaptive replacement cache. So it has essentially two levels of cache here. It has a sort of probationary layer of cache, and that sort of exists for temporary caching purposes. And so something, if it's not in the main cache, gets put into this probationary cache. If it's going to be accessed again, it then gets put into the main cache. Otherwise, it gets removed eventually from probationary cache. It does also use the other two mechanisms that we mentioned to work out what items should be removed from cache, how frequently we might purge certain elements of the cache. Should we purge everything in the probationary cache? Should we purge only what we need? Do we need to keep everything in main cache? But this one, it requires the most amount of work. So why should you know this? Why should you know the inner workings of cache? I mean, can't you just wrap this in an if statement and just call cache and do everything? And you could just do that. But in the end, understanding how cache really works allows you to make more intelligent decisions about what you're going to go ahead and cache. For example, one of the rules that you might want to follow is that you want to cache data that changes frequently, apart from data that changes infrequently. So let's say you have a list of posts, and those posts have a list of likes, and those likes have names attached to them. The easy way would be you simply query the database and then join the likes tables onto the post tables and present it to you in a nice, easy table, and you can export it out to the client really simply. So now you have one database query that goes out, does its job, comes back, and you cache that result, and it has everything you need. But what happens when somebody likes one of those posts? Well, suddenly the cache is out of date. So now you can either A, invalidate the entire cache, B, read that cache, add that one like to the data structure in that cache, and then reset the cache, still sort of invalidating it. Or C, remove the likes from the actual data that you're caching. It doesn't mean you don't cache the likes. It doesn't mean you don't cache those usernames. It just means you don't cache them in the same location. It actually becomes somewhat easier if you just simply get the feed posts that are available to you, cache that as one call, and then get the likes and cache that as a second call. And so now what you're doing is when you go out to get this one feed of data with the likes and the usernames attached to it, it's going to be two memcache calls, one for the feed, one for the likes, and you simply take the likes and you put it on top of the feed, and you return that. And now when somebody adds a new like into it, you only ever need to touch the likes cache. You only need to add it there, and that's probably a much easier structure to update. It's a much smaller structure to update, updating a count of likes, updating a new user ID or a username to that. Because much easier to work with. Remember, you have this giant feed of data that you're sending back. You don't want to be sending that over memcache, getting that from memcache, updating and sending it back to memcache. Remember those numbers that we looked at previously, the amount of data being sent back and forth? That's milliseconds there. That's 5 milliseconds, 10 milliseconds in operations. So you want to allow yourself the ability to look at cache not as one single data point, but as different layers. So one thing we could also do is never even save it to the database in the actual request when we're updating cache. So let's say go back to that feed and like example. You have the feed. That feed does not update frequently. All right? You know when it gets posted to, or you know who's posting to it. You control that. But the likes are happening all the time. So what you do is when somebody likes something there, what you could then do is update the cache and then send it out to RabbitMQ or another message broker to do the actual database update. And we'll get to that. We'll get to that in the third part. We'll talk about RabbitMQ and how to do that. But that way, all you ever do when somebody likes the page is you're not updating a database, you're just updating cache and then sending a message to RabbitMQ, which is incredibly fast. On a side note, I do want to talk about ORMs and cache. My experience with ORMs is that the caching they provide is rudimentary. I could be wrong. This could have changed. But last year, a colleague of mine used a ORM, and it claimed to have caching available. And so he built out his application and didn't look at caching as an option. He just said, I don't need to worry about caching right now, or the ORM has caching. The problem is that the ORM's caching was very weak. It literally took whatever was passed in as an argument and simply cached that. Now, if you have queries that are dependent upon the member ID, this means each member's cache is going to be unique to that member. So that member can't benefit from another member's cache. So if they're seeing the same feed with some very minor differences, like whether they like to post or not, they don't benefit from each other's cache. So I'm not saying stay away from ORMs and don't use their cache. Make sure you understand how their caching works. Again, it's not just a simple switch that you can turn on and suddenly you have caching enabled. So actually test it out and see what you're actually getting. So back to this. So which one would we use here if we wanted to limit the number of members stored in the member list?
Tool, delete the
least recently used, least frequently used, adaptive replacement cache. Does anyone have an easy answer for that? Exactly. Depends on the use case. This goes back to what we've been talking about before. You need to understand what's going on. There's no simple solution. You need to understand the business requirements. You need to understand what's going on in that application. There's nothing that says, hey, use this one cache for everything. There is no one rule that says, oh, use this cache for this, use memcache for this, use APCU for this, use Redis for this, use MySQL for this. You have to understand how your application is actually being used. Do want to point out, some of you might be looking at this. I know I mentioned that the member constructor was doing the database call. I know there's like reasons not to do that and stuff like that. This is just for example purposes, but this was actually mentioned to me when I sent the slides out for review. Someone's like, you shouldn't do the database stuff in the constructor. That should be abstracted out. I was like, that's not the point. So, let's say this is the scenario. The member object usually first grabs the logged in member. So in the life cycle of this application, the member object's first thing it's going to do is it's going to grab the member, that's the logged in member. And then, let's say on the page, it grabs the other members that are on the page, right? And then it goes back to maybe grabbing others, then other systems might go back to grabbing other member information. Then, which one would we use, depending on this use case? Again, it could be based on a lot of other things. In this case, with this sort of application structure, for what we did was we went with least frequently used. We found that to be the most performant method. That seemed to be the most helpful method. But again, it came down to testing. It came down to figuring out exactly what our use cases were. And we implemented this, and it seemed to do the job. But it's not something where we're simply going to do this every single time. We don't simply default back to using this method of caching. We don't simply say, oh, well, that's the one we used that time. We're going to do the same thing this time. It was also relatively quicker to implement this than it was to implement this and put all the logic behind that. And so we went with the easiest route right here, which was least frequently used. And again, this is why we did it. It's fairly easy to implement, it fits our needs, and it's good for many of the systems that are relying upon this class, or this class's version at MeetMe. But, I mentioned this before, if this is just going to be used on the web, you probably won't run into a situation where member list grows too large or it's going to be an issue. It might be an issue. I've seen cases where this has caused a problem on the web. We've had to go back and tone things down a bit. But and when we talk about rabbitmq, this is going to become more apparent. If you were to use this in a long-running process, you're going to have two problems. Again, one, this could grow so large that it becomes an issue if you don't do something about it. But the other problem is that the data in here might become stale. And so this is important. This is a question that you need to ask yourself. Because if we put a member in here, in this member list array, and then we move on, and then we come back to that member later, and that member's data has changed in the database, this data is still not going to be updated. And that's a problem in cache. The database is updated, but the cache isn't updated. So we really need to ask ourselves, what do we do about stale data? Data that is no longer live. Data that is no longer 100% active. And it really goes back to that question in this specific case. So, if that data is updated, it becomes stale, it's no longer entirely valid. And the question that you need to ask yourself for your application is, does that data being stale hurt your application? The default answer is not yes. There's a couple questions you need to ask yourself about the data that's being stored. Does your application use mutable data? All right? Mutable data, data that changes all the time. Someone's online presence changes rapidly. So that's something that if you cache it, could be wrong. But maybe you just want to cache it for a minute. That's still cache. You cache it for a minute. If they were on in the last minute, maybe that's okay for your online presence. But things like the birth date, that's generally not going to change. If someone adds in their birth date to your application, they're generally not going to change that. Their username will probably not change. And so having that be outdated for 10 seconds, 20 seconds, having that be outdated for a minute or 5 minutes might not be that bad, depending on where it exists in your application. Does your application use privacy-centric data? Oh, let me tell you, the last thing you want to do is cache somebody's settings that says, yes, everyone can see these posts, then have that person change it and then post right away, and the cache not have updated, and now that post goes out to the entire world. So make sure that when you're caching things, you understand what you're caching. This doesn't mean you can't cache privacy-centric data. It just means that when you need to up that data, you need to update that data in line. You need to update that cache right away. You need to make sure that that cache is updated. Maybe there's legal reasons that you can't store things in cache, or that cache can't be out of date. Maybe there's business reasons. Who here has ever done any work with PCI compliance? Credit cards, I'm sorry. I'm sorry. I had to do that for 10 years. Never again. So, does the data being stale hurt your application? You can have a yes. It could be no. Really, the answer is both. Yes or no, it all depends on your application's needs. It all depends on the data. So, really comes back to a lot of these things I just said. You need to understand the needs of your business. You need to understand the legalities, if there are any. You need to understand how you're using that data and where that data is being used. You can't just say that all data that's in cache needs to be accurate all the time, 100% of the time. Stale cache can work. If his username, he's updated it, a minute for that update is not mission critical. It might not be, might be. It might be mission critical. It might be mission critical in certain areas. It might be mission critical in other areas. In a login sense, that might be critical because now he wants to be able to log in. His updated username is important. But maybe on his profile page, okay, we can let it go. So having different layers of cache is important. So again, normally in a single transaction, a member's address might change. Let's say they're ordering something online and they go ahead and they have their address in there and they place that order with that address, right? But what happens if they then change that address really quickly, before your system goes to the back-end system and that back-end system processes it? What should happen? Before that transaction is finalized, before it says complete, so it's saying it's pending. And then it gets into that complete state. So in that pending state, he changes his address. What should happen? Should the address change be applied to the transaction? I mean, after all, it's now updated. So shouldn't we use the most recent data? But he made that order with that address. So there's no easy answer. It's all about understanding your data. When you think about that, you're like, well, if I was in a situation where I have to update my address, let's say I place that order and I go, oh my gosh, I need to update the address right away. Go update the address. Well, maybe you provide some mechanism within the order to change the address. Maybe you look at it and go, okay, well, maybe instead of simply changing it, we say, hey, we noticed you just placed an order. Do you want to apply this new address to that order? But again, in other cases, if someone wants to update their privacy settings, we really want to make sure that we update those privacy settings. Is that clear? Everyone following that? So if someone has a question, I don't know, it's on the slide. You like these animations? I did these animations with squares and rectangles and circles. So, caching. Caching isn't something that you can say, let's just add it on at the end. It's something that needs to be planned. If you add it all in at the end, you're going to have problems. And the reason for that is cache is a data store. It is a location where you are getting your data. Now, I want you to think about that for a minute. Cache is a data store. Who here has ever worked on a project where you built the program and then decided the database schema after it was all written? Dude, I do that all the time. That's a horrible way to go about doing things. You want to understand how your data is going to be stored, the schema of that data. Even if you're using NoSQL, it's still going to have a structure. There's still going to be an object that's returned that has the data that you are expecting to be returned. And if you don't understand how that data is going to be stored, you're going to have a problem. And the same thing applies to cache. So don't wait until after you launch to figure out how you're going to do caching. And I say that because, again, I had a colleague do this. They waited until after launch. We were in load testing. They didn't have cache enabled because the ORM could do it. And when we went to try it, it didn't work. So caching should be something you do by default. It doesn't mean you have to cache everything. I've released applications where I blatantly say, well, the database server is way too fast for what we need, but the money was already spent, so we're going to use it, and we don't need to add cache in here. But if I need to go in and add cache, I already have it all planned out. Be at least in that situation. Don't just say, oh, we're going to add cache when we need it. Have it planned from the beginning. So even encode cache has problems. So we showed the example with the encode cache with the little members list. In this case, only one process has access to that data. So that request only has access to that. And if you have 20 requests, you're still making 20 requests out to the database to get that data. So for web requests, that local cache is only available to that single request, and any other future requests do not benefit. So we need a solution that allows for multiple processes to share data. And this is where we get to the big argument, the big confusion, the big debate. Memcache versus APC or APCU. It's APCU now in the latest PHPs because APC doesn't work with PHP 5.4 or above or something. APCU is supposedly a drop-in replacement for APC. At MeetMe, we're running on, the latest PHP version we're running on is the latest PHP 5.3.2.8. For some old web code, we're still on PHP 5.2.9. But we're migrating to 5.3. But APCU is supposedly a drop-in replacement. So you have a choice when you're deciding on caching systems in PHP. You have a lot of choices, but primarily the two you're going to be choosing is between Memcache and APCU. So over here in your left corner, we have Memcache. It's externally accessible. You can share data across multiple systems. It's really easy. Everyone knows how to use it. Most everybody. On the right, we have APCU. It's incredibly fast. It's local to your machine. And there's no need for another server setup. There's still some configuration you need to do for APCU, but it's really fast because it's local. You don't have to go out to a network. You can set up Memcache locally, but generally people set it up on its own server. So which one would you use? Which one's the better solution? Which one is the one that you should go to? The problem is that they both serve different purposes. They both excel in different areas. And it all depends on the data and what that data is being used for. And I know what you really want was an answer that says which one was better, but I don't have that for you. So, remember when we were talking about layers at the beginning? We were talking about different caching layers. We had local cache, external cache, and remote cache, and they each do different things. They're each responsible for different areas. Well, this is where they sit, APCU and Memcache. And you can use Memcache and APCU together in an application just fine for different reasons. For example, for APCU, for this local cache, because it's accessed locally, you can store small data. It's really useful for storing small amounts of data. Data that's frequently accessed, that's infrequently changed. So something like the state country lists, right? We've all had a table in MySQL that says states, and it lists out all the states. And we had another table that says countries, right? And then we want to fill out that select box on the web page. We go out and we do a select all countries, and it fills it all out, and that's what we do. And maybe in that country list, there's an enabled, disabled, so we don't trade with North Korea, right? So this is nice. And then you could store that in Memcache, but why are you going all the way out to Memcache to get this data? Why not just store that locally, APCU? Just store it in APC. It's not going to change. I mean, when it does very infrequently, okay, maybe then it needs to be updated, but then you just update the APC cache. It's really simple. But you don't want that. That's something you shouldn't have to worry about. And it's not something that needs to be shared out. That you need to have one copy of it that needs to be shared amongst all the web servers. Each web server can have its own state and country list. You could also add configuration. If each of your different web servers might do different things, might be different tiers. At MeetMe, we have web servers that are responsible for the feed. We have web servers that are responsible for the profile. We have web servers that are responsible for just the API. And these services connect to specific databases. And we store that database configuration in APC, in cache. So that way, we don't have to actually go out to some third party. We don't have to actually read it from anywhere. It's all within a local cache. And there's no reason to store it on memcache. We could have multiple layers of cache, but we don't. Memcache is really useful for things that are accessed over the network, storing larger data, things that are more frequently changed, things that are more volatile. Member data, for example, you want one consistent, at each level, one consistent level of member data. So you want, when you're getting the cache of a member's data, you don't want to have half the servers, half the APC servers saying, this is the member data, the other half saying, this is the member data, and not knowing which one's correct. Because half the time, someone will be landing on the web page and they'll see this profile information, and the other half will see this profile information, and it'll look like a bug. You want that data to be centralized. And this means storing it in as few places as possible. And so in this case, memcache, member data, or other production information, things that might change, things that should be shared out amongst everything. So we're going to look at architectural overview of how this all fits together. So in this case, you might have a config service like Zookeeper. And what's going to end up happening is the login tier, or the profile tier, the chat tier will go out to this config service and will get the primary configuration. And then it will come back and add that to APCU. And so next time it accesses APC for that configuration to figure out which database it should access, it only needs to go to APCU, not to Zookeeper itself. And this keeps the configuration very local. I mentioned Zookeeper. Zookeeper, this is again a very short little thing here, but it's an Apache. Apache Zookeeper allows you it basically does configuration management. The nice thing about it is that it can push changes out to different clients. So you could have it say, oh, we've gotten new changes, go ahead and update. And that's how it would be used in the previous slide. You'd have services that would sit there and update APC when the changes occurred. And so the web clients would never actually have to go out to Apache, to Zookeeper service. So if you're looking for configuration, some sort of system that manages configuration, highly suggest you take a look at Apache Zookeeper. So, memcache. How does this all work with memcache and trying to save data with memcache? For those of you who've never used memcache, what you're going to end up doing is the first thing you're going to do is you're going to make a request out to memcache for data. So let's say you're going out to the database and you'd say select first name, last name, email from members, where member ID equals whatever. Member ID equals 1. So that's the normal way you do it. With memcache, you'd first check memcache, and you check to see if member ID 1 exists in memcache. When you don't find member ID 1 in memcache, you're then going to go out to the database and return the results to your web server. And then you're going to take that data and you're going to put it back into memcache. So now you have memcache storing member ID equals 1, and this is the member information. You store the member information in memcache. Then a subsequent request will go ahead and make a call out to memcache and see that member ID 1 exists in memcache. It'll return that data. You never have to go out to the database to get this. You never have to go back to the database. So we're going to look at actually using memcache and adding that to our member class that we looked at before, our member example code. So here we have, again, the class member. We have these same, we remove the constructor there, so we know what that does. So we have get member. What we want to understand here is that we allow for an external cache to be provided. So we can use whatever caching mechanism that we want. In this case, we're going to use memcache. I highly suggest that if you are using caching, that you're going to add caching, that you abstract that away behind some facade. So you're not actually going to be accessing memcached, or you're not actually going to be accessing the APCU functions directly, but that you access some sort of facade above that. And this makes changing things out easier, or adding different functionality or enhancing the functionality of memcache a little bit easier for you in the future. But anyway, so we can pass in our memcached object. And then what we're going to do here is, if we find that this is set locally, and again, we're still using this local member list, what we can do here is we can simply say, get it from member cache key. Oh, sorry. This does the whole checkup here for the is set, and we're closing that off right here. It just returns it still. So if we generate the cache key, which is done down here, and the cache key is member : member ID. So we get the cache key, and then we're going to go out to memcache right here, and we're going to say get member : member ID, and return to me the member. And if it returns the member, then we say we're using a memcache member ID, a member, and we're going to store that member that we got from memcache into the member list and then return that back from the function. So this is simply just like the member list check we did up here previously, except we're now checking memcache before we ever go out to the database. And then down here is when we'd go ahead, we'd get the member, and then this does the simulated database call. And then we add it to memcache if it was never in memcache in the first place. Now the other thing we do, we're adding it to memcache, but we're also adding it right here to the local cache as well. And again, for a single request in web, this makes it very easy. This is very easy to set up. And this makes it very performant. So not only are you storing it in cache for other requests, those 20 other requests that are coming in, those other requests will now be able to benefit from it being in memcache, and they'll only ever have to go to this point to get that member information. So we're going to look at another script here. We're going to look at the same script we had sort of before. We're going to add a couple of members in there. We're going to create a connection to the memcached running locally. And now we're going to actually run that. So now I want to stop right here. So the first time we're running this using an uncached member, that's member ID 1. Next time we're doing a locally cached member. And then again, we're using a locally cached member, but 2, 3, 4, and 5 are all uncached. So this is the first time we've run this. So there's no memcached gets in here. We're using a locally uncached version, and then locally cached for the next 2 subsequent recalls for member ID number 1. And then 2, 3, 4, and 5 are all uncached. So everything we essentially had to go out to the database for except for these 2 right here. Now, we're going to run it a second time. We're going to see what happens with the caching that we've used. So this time, we're using memcached for member 1, and then we're getting locally cached member ID 1 information there. And for 2, 3, 4, and 5, we're all getting it from memcache. And that's because the second time we've sat there and we've warmed up the cache, and that cache now contains all the different member information that we might normally have access to. So let's actually talk about what gets stored in memcache. So in this, if you remember in the code, we were actually storing the class, member class, in memcached. So you could take a class and store it in memcache. It's not a problem. But it's going to look a little bit interesting. So we're going to go ahead and look at what happens. So we're going to set up memcache. We're going to set up. This is so much easier than actually having to type it out. These are my live demos. They were done live at the time of recording. So we did cache. We're going to dump the cache get member1. So here, what we see is it returns. So we've added this cache. Now this is from the previous run. So we were running this previously. Again, you could see how we ran the script, PHP script before. And now just from the command line, we're able to access the local memcache and we see member1. Here's what we get back from member1. And you'll notice it's PHP incomplete class. And the reason why is we were storing within it a member class. Now, member class in this context doesn't exist, so PHP doesn't have any clue. So we're going to go ahead and we're going to try to solve that. So I'm going to inline create a class member. I'm going to create a protected member ID. And I'm going to create a function called getMemberID. So there's our entire class, and we're going to get this again. And now you can see that the object is in fact a member, and that when we get this, we'll be able to actually call the getMemberID because it's returning the right class. So we call them the getMemberID, and it will actually output the correct member ID. You get, in this case, member ID 1. So right there at the bottom, you see it's returned 1 as the member ID. It's right there. When you are storing classes in cache, when you get them out again, you need to have that class already defined. You need to have that class defined. You are free to store whatever you want in cache. You can serialize it or encode it into JSON if you want, and then de-encode it from JSON. So you can store JSON in memcache, and that actually might be a preferable way. The problem with storing something like this in memcache is it becomes very specific to PHP. So if you have a Python consumer that needs to access memcache, or you have something written in Node.js, or you have something written in Ruby or something else, when it gets this information, it's not going to easily be able to access it. Now, there's probably libraries out there for each of those classes, or each of those languages, that allow you to deserialize a PHP class and turn it into something that's usable by the other classes. However, it is something to consider. It might just be easier to store this information as JSON. However, if you're entirely PHP-centric and that's all you're dealing with, this might be an easy way to go about doing things. Getting an object back from memcache might just be something that's a little bit easier to handle. Let's talk a little bit about overwriting in memcache. So memcache doesn't have any concept of who owns something, so you can easily overwrite things. So again, I put all my configuration up into config.php, and now it returns a memcache object. We're going to go ahead and set something here, member 1, and we're going to overwrite whatever was in there to just 1. And now, when we go to get this out, it's going to return 1. And this is important to recognize. Member 1 is going to return 1. Member 2 is still going to return the data that we set there originally. The data that you store in there into memcache or any cache system could be considered corruptible by whatever allowances you make for people accessing that cache. So if you have one PHP consumer updating that cache, but something else also suddenly starts to update that cache, they may not come back compatible. So what you should do when you're dealing with memcache is make sure you validate what you're getting back. Don't assume that what you're getting back is what you put in there, because it is an external caching system. Because yes, I updated it here, but if I went back to my other script and I expected that to be a member class. This is not a member class anymore. Member 1 is not a member class. So I can't assume that just because I stored it into Memcache, no one else has updated that information. So you should definitely validate what you're getting back from Memcache to make sure it is exactly what you expect it to be. Don't assume. Treat it like you would user input. It's an external data source. Cache expiration. So with Memcache and with APCU and with other caching systems, you can expire cache after X amount of time. So we're going to go ahead and we're going to set a cache key of foo. Bar. And then we're going to set the time to be 20 seconds from now. And then we're going to go ahead and get this, and it's still there. And we're going to try to get it again, and it's still there. And try to get it again, and it's still going to be there. And then 20 seconds after we've run this, when we go to try to get it one more time, we're going to find that it's not there anymore. It's important to note that it's going to return as false. So just keep that in mind when you are storing in data that can be expired, and that data could be Boolean, and it can be false. So you don't assume that just because it's false that it's going to be that it's the actual setting. It could be that it's expired. Memcache also allows for callbacks. So we're going to go ahead and get member 11. Nothing comes back false. So what we're going to do is we're going to create a callback. And what this does, the callbacks that Memcached provides in its library is if it doesn't find the data that you're after, it will pass you this information and allow you to go get that data and then set that data that Memcache will then store. So in this case, we're going to get member details. It's passing us the Memcache instance, the key, in this case member 11, and it'll pass us a reference to the value. And what ends up happening is we assign whatever value we want to the value variable, and we return true saying we were successful. And now, when we simply say get member 11 and then pass the callback here, what it's going to do is it's going to say it didn't find member 11, and it's going to run this function instead and then store that function into Memcache. And then when we come down here and we just get member 11, it's already found it because it was stored up here in get member details when it was running the get with the callback. There's also something that's important called check and save in Memcache. A lot of this comes from the fact that you could go out to Memcache and get the data, and then when you go to update the data, you may be over the timing between when you got the data and when you're saving the data, that data in Memcache might have been updated. And so what we want to do is we want to be able to use check and save to go ahead and fix that problem. So here, we're getting this key. It doesn't exist. So we validate that that key doesn't exist in either instance of our PHP shell. And so right here, what we're going to do is we're going to use get member details, and we're going to use a check and save, and then this says this is user 12, just like it says up here in this function right here. So now, this value is set, this CAS, check and save, is set to 0. This is the key that Memcache returns. So now we're going to set this key that we had set before, the same key that's right up here, member 12, and we're going to set it to ASDF. And now over here, we're going to cache, check and save using the cache key, using the check and save value, using the key, and we're going to set the value to be update. And what you're going to see is that memcache won't allow us to actually update that data because it knows that the check and save value is different. It has been updated between when we originally fetch the data right here and when we go to set the data right here. So this is useful if your cache is something that can't or shouldn't be updated after someone else has already updated it. It's generally not an issue. People don't, generally people I've seen don't treat memcache like that. It's a whoever writes last wins, but it can be useful. It can be useful if you need to know that. Basically, it saves you from race conditions. Again, it's not always a problem, so don't always worry about it. Talking about cache, I do want to branch out just a little bit, and I just want to take a side note and talk about CDNs. If you ever have the opportunity to use a CDN for your public-facing app, I highly recommend looking into them. Content delivery networks allow you to get data to users faster. It's sort of like a cache, but really what ends up happening is they put that data closer to the user. It can make a tremendous impact for a lot of static data. The nice thing now is that a lot of them are offering API acceleration. So they actually make it so the person, let's say your mobile device only has to connect to the local POP that they have available. And that has a direct connection to your server sitting wherever they are. And they make those connections a lot faster than they would over the user normally would, so they can increase the API performance. So going outside and looking at CDNs and API and seeing what they have to offer is definitely recommended. I've seen tremendous performance improvements when using CDNs. We're going to go through this quick, primarily because we're running short on time when I have to still go through rabbitmq. So we're going to talk about data sharding real quick. Who here is familiar with data sharding? Okay. Someone asks you to shard data, you'd be like, I don't know. Sharding data is actually really easy. It's not that difficult. Basically, it's taking one set of data and splitting it up logically. So normally, in your PHP application, you're going to have PHP application talking to a single service. So maybe this service is your database. Maybe it is Redis. Maybe it is a RabbitMQ node or something. Whatever that service is, whatever that external service is. You want to take this one PHP application, and actually with sharding, you want to be able to have that PHP application talk to multiple services. These are all the same service, just different nodes. So this might be database 1, database 2, database 3, database 4. Okay? And so this is useful if you have a lot of members and you want to be able to say, well, I want 25%, I want to split up our members into 4 different databases. So 25% of our members should be in this service, 25% should be in this service, so on and so forth. You do that with data sharding. The easiest way to do data sharding, and I bring this up only because I realize that a lot of people I spoke to didn't understand this, how the basics of this worked, is that it's really simple to do. You have 4 different services right here, 1 PHP application. The simplest way to do this is to do a mod. And you have an ID, you do a mod, and then the number of services. So in this case, this would determine the shard. Your ID, your member ID, let's say, mod the number. So in our case, we're going to do the ID of the user, mod 4. And this will give us a return of 0, 1, 2, or 3, because mod gives you the remainder. So from this, we know which shard to use, 0, 1, 2, or 0, 1, 2, or 3. And that simply can be stored in an array in PHP. And it simply says, OK, I'm going to use these connection parameters to shard it out. So the way that's going to look is, in your PHP application, member ID mod 0, with the result of 0, will hit this service. With the result of 1, will hit this service, 2, this service, and 3, this service. So if we had a member ID of 1,000, mod 4, and we had 4 database services, that is going to hit the first service. If you had a member ID of 2,567, using that same method, this would hit the 3rd service right down here. And if you had a member ID of 3,446, you'd hit this service right here. Now, the important thing here to note is that you could have these sharded out and going to the same service. It could be preparation, seen as preparation for future expansion. The number of shards that you split out, the number of, doesn't have to equal the number of shards that you actually store, that you actually have available. So in this case, member ID 0, member ID 1 both go to the service, this service, and member ID 2 and member ID mod 3 go out to this service right here. Any questions? I know it was a bit fast, but I wanted to give you guys a break because next we'll be talking about message brokering. And we're going to get really deep into rabbitmq and talking about how to write consumers and publishers. So I guess we'll take a 10-minute break. So there's been some questions about the slides. I will be posting the slides onto Joined In. There are 2 slide decks. I'm going to probably try to combine them into one to make it one easy slide deck to download. But there are movies in both these slide decks because I tend to not like to do live demos because they have a bad habit of not working. So I'll also be including the movies probably as a Dropbox download or something else. And then I will also probably try to get you guys the actual Keynote files for the actual presentation. So if you have access to Keynote, you can actually get the raw, the Keynote decks and everything. You can actually see I did the really cool animations and stuff like that. I want to give you guys as much as possible. If I, for some reason, forget, as I told the other gentleman, feel free to berate me through whatever social media platform you choose. I'm here to help you. If you have any questions after the conference too, you have my contact information. It's in the slides. I'm Jason Lotito everywhere. Feel free to contact me. I really want you to get the most out of this. So if sometime down the line, if a month from now you decide to use RabbitMQ or using Memcache and you have some questions or something like that, and you're like, I remember Jason said something about that, but I completely forget. Go ahead and email me. I don't mind. I will try my best to do what I can to help you. And if I don't know the answer, I either will try to find the answer or I'll direct you to somebody or direct you to some documentation that does have the answer. All right. PHP, rabbitmq, and you. This is actually from a talk I did at Midwest PHP, but I love this talk, and I think it's a wonderful presentation, and it carries so well into what we're talking about, what you should learn after PHP and MySQL. And this is because RabbitMQ is a wonderful technology. And not just RabbitMQ, but message brokers in general. So, get a quick understanding of where you guys are at. Who has worked with RabbitMQ in a production environment? Awesome. Has anyone worked with RabbitMQ at all? Played around with it? All right. And has anyone used something like ActiveMQ or ZeroMQ or some other queuing system? All right, Beanstalk, all right. Sorry? Gearman, okay, Gearman's one, all right, Gearman. All right, cool. All right, so that's cool because a lot of you, this is going to be your first introduction into a message broker system and RabbitMQ in particular. So this is going to be a crash course. The first part of this is going to be a crash course in the RabbitMQ. The terminology, what we're going to be talking about in RabbitMQ. The second part is going to be touching on PHP and RabbitMQ, how to use them together. We're going to see some code, some examples of how they're employed together. And the third and final part will be some common things that you should do when actually working with RabbitMQ in production, when working with queues, when working with messages, and other things, and other tips and advice that I'm going to offer up. So, what are we going to talk about here? We're going to talk about what RabbitMQ is. We're going to do a technology overview. We're going to talk about publishers. We're going to define publishers. We're going to define consumers. We're going to define what exchanges are. We're going to talk about queues, and we're going to talk about what bindings are. Don't expect you to know what all those mean right now, but hopefully by the end of part one, you'll have a bit of familiarity with them, and we can have great success with that. So RabbitMQ is a message broker. It's a queuing server. And it basically lets different applications share data and events via a common protocol. And it allows you to queue jobs for processing by other workers. Really, what that means is your web server can tell some other system, or it's a distributed event system, I guess is the best way I could describe it. So this is where RabbitMQ sits. So here you have your PHP application, and here you have consumers. All right, this is the architecture of a typical RabbitMQ implementation. And we're going to define what each one of these means. So on this side right here, your application, this is your PHP code. This is in RabbitMQ world. This is also the producer or the publisher. This publishes events. And when I talk about events, I really mean events. Think of a database as sort of like that place where you store your data, and a message broker or RabbitMQ as the place where you send your events, things that occur in your application. And the things that occur in your application come from your application. So when an event occurs in your application, it is sent to RabbitMQ. It is sent to something called an exchange. So the publisher publishes to an exchange. This exchange receives events from publishers.
So you can kind of step up.
What happens after this is that this exchange sends these events or messages to various queues. These queues are subscribed to various exchanges, and these subscriptions are called bindings. So you have a message, it goes from, you have an event or a message, it goes from application, your application, over to RabbitMQ's exchange, and from the exchange, it passes it over to queues that are listening. And from the queues, it then passes it on to the consumers. And these consumers are external applications that are written by you that listen to the queues. And every time a queue gets a message, it pushes it, it sends it to the consumer. Is everyone clear on that?
And re-implement.
So again, whereas a database handles your data, a message queue handles your events. Sort of like, it's sort of the event system in JavaScript. If you can emit an event there and you can listen for events, RabbitMQ is sort of like that system. You could also think of it like this. A database handles nouns, a message queue handles verbs. So a database would handle members, it would store members, but a message queue handles member registrations. What I mean by that is when a member registration occurs, the message or the event is emitted to RabbitMQ along with the associated data with that member registration. But let's see some actual code. So in this example at the base level, we're going to be using this PHP library called PHP AMQP lib, and you can access it via Composer. And we're just going to start with the publisher. We're just going to start with this side of the application. So all we're doing here is we're sending an event from the publisher over to RabbitMQ. So this is the code. You can tell that this is a different slide deck because I'm doing completely different styles here. All right, so this is the code. Now, the important thing here is that we prepare the message. So this is, we do all the boring stuff, config, whatever. Here's the thing. We do AMQP connection, and we pass in the configuration for host, the port, the username, and the password. Pretty common stuff. And now we have this connection right here. We're going to set up a channel. This channel is the way we communicate with RabbitMQ. It's the channel that we communicate over between the publisher and the server. In this example, what we're going to do is we're going to take whatever is passed in via the command line. We're going to pass that in. We're going to put spaces in between, and we're going to set that to a message. And if it's empty, we're going to make it hello world instead of an empty message. And then in this script, we're going to go ahead and do a publish, and we're going to send it an AMQP message, and we're going to send it over specific things. We'll talk about that later. And that's it. So this is the publisher. This is a simple command line script that we're going to run. It's going to go ahead. It's going to publish a message to rabbitmq. So now we're going to create the consumer. We're publishing this. We've built this part. Now we need to build this part, because everything inside this box is all rabbitmq. We'll still have to do some work in there, but we don't have to write any code for that. So to do the consumer, to write the consumer, we're going to write a script called receive.php. And in this one, again, we have your basic connection stuff. We are connecting here. We're still connecting to the channel. But one thing we're going to do is we're going to declare the queue. Now we're going to declare this queue to be called hello, because hello world is a traditional starting example. Now you'll remember we used hello in the previous publisher code that it was publishing to a queue called hello. So in this way, we're saying, we're declaring this queue hello right here in the code. And what we're going to do with this is we're simply going to take the message in and we're going to echo that message out. We're going to print the message out to the terminal. And finally, down here, we actually tell the channel we're going to do a consume on the queue, the hello queue. And all this other stuff is not important right now, other than to note that we have to pass in the handler, which is the function that's actually going to be called. So this we'll get to later. So let's see this actually run. So I believe at the top, we're going to set, this is the consumer up here. This is going to receive. And this is the sender, PHP send, PHP hello world. And we see that it's sent here, and then it's received up here. So we have two different processes of PHP, one that's waiting for messages and one that's sending messages. We sent the message, it receives it up here, it outputs it, and that's it. And now it's rabbitmq. So what happened? So the application sent the message to the exchange, and we want to talk about exchange types here, because inside of this, there's a lot of stuff that we can do. So we're going to talk about three different exchange types. We're going to talk about direct, fan out, and topic. There's actually other exchange types, but by and large, you're going to deal with these three right here. In fact, you're mainly going to deal with topic. All right? When you start off, doing everything in topic is probably your easiest bet. You can explore direct and fan out. It might offer you optimizations that topic doesn't. There's also one for headers, and I believe there's other ones as well, but we don't need to get into those. So, the different exchange types. Exchange types decide how an exchange is going to share out messages to queues that are listening. It sort of sets the rules for how queues can subscribe to exchanges. So, let's say we have this direct exchange. And this direct exchange is going to be called messages. And we have this system right up here, this routing key, that we want to send to different, this routing key called message new, this routing key called message delete, and this routing key called message viewed. What we're going to do here is this direct exchange says anything with the routing key message new will go to this queue. Anything with the routing key of message delete will go to this queue, and anything with the routing key message viewed will go to this queue. It's direct. There's no chance for saying I want everything that comes through. I want message dot something. We'll get to that in a bit. Direct says this goes right to here. It specifies exactly which queue it's going to go to. In this case, now the next case is the fan out. So we have direct and we have fan out. Fan out sends to all the queues. It gets a message, it sends to any queue. So any queue that's listening to the fan out exchange gets the message. So for example, if you had an exchange called logs, anything that's listening will get all the logs. Every message that's passed into the log exchange, it would send out to each of the queues. Now, the topic exchange sort of does both. But it allows you to put wildcards in. And this is why I say that this is probably the one that you're going to stick to using when you're using rabbitmq. Because here, let's say you have your messages exchange. And messages exchange can receive message.new or message.delete or message.read or message.reported. It can receive any of these events, any of these messages coming in with these routing keys. Your first queue up here is specifically looking for messages.new. So anything that matches this routing key will be sent over, just like in the direct exchange. So topic exchange, the exchange here, the message exchange, will say anything that says messages.new will be sent over to this queue. This queue right here is saying, give me anything that ends in delete. So what it's going to do is it finds something called message.delete. It'll send over to this queue. If this, for some reason, got a message called thread, let's say your messages exchange not only received messages, but also received thread events. So you have a single message as a part of a thread. And so let's say this exchange receives anything related to messages, which might be messages, might be threads, might even be members acting upon those messages or threads. So this right here, this queue is going to receive anything .delete. So messages.delete, messages.delete, thread.delete. Down here, this is going to say, I want anything dealing with messages. Anything that's prefixed with messages, and anything after. And this can be anything as far as it goes. We'll get to that, the difference between a star and a hash in a second. But you get messages.new, messages.delete, messages.read, messages.reported, all go to this queue right here. If something came in that was a thread, had a routing key thread, so messages with a thread.new, this wouldn't get it. Excuse me. Wow. Just lucky. So, you have a queue bound. You can have a queue bound to many exchanges. So let's say you have this single queue right here. Remember before we had the anything.delete? You can have this deleting queue, and all it does is say, I can take a message.delete, I can also take a photo.delete. And I know how to delete both messages and photos. So this single queue can read from multiple exchanges. It has bindings to multiple exchanges. And so you can have a queue that handles multiple things. It doesn't have to only read from one exchange. Now, when this is set up, what this actually looks like in code is when you set up your AMQP message and you run basic publish, you send your message over, the routing key is right here, messages.new. And messages.new in this case is going to go up here. It's going to go to this one. It's also going to go down here to this one. That's because these queues are going to be doing different things. Let's talk about what these mean. The asterisk, the octothorpe, and the period. So the asterisk, this has also been referred to as a sextile. Actually, this is an asterisk. The sextile, I think, has 6 points, but it doesn't make a difference. So the asterisk matches one word. So if it's asterisk.new, it's only going to match messages.new. It's not going to match thread.messages.new.
This whole thing called like this namespace,
the
routes and
the number sign, the pound sign, is going to match 0 or more words. And a word is delineated by the period right there. And so that's how you namespace everything. That's how you separate everything. That's why we're using messages.new, and that's how we're using that in the routing key. So in this case, messages.new are going to match asterisk.new. It's going to match messages.asterisk. But it's not going to match asterisk.messages.asterisk. Something like spam.message.new is not going to match spam.asterisk because it's expecting only one word and it's got 2. It will match spam.asterisk.asterisk and will also match spam dot pound sign. Now, let's actually create an exchange and a queue. We're going to use the rabbitmq management UI to do that because it provides a really nice UI. And the nice thing about this UI is not only does it provide the UI, but it offers a RESTful API that outputs JSON. And the management UI uses that same API, which is really nice, because you can also access that API and do some really cool things. The management UI, the API, actually, if you remember the rabbitmq memory node Graphite chart, actually used the management API, the management UI's API to generate the data for that. So it's really easy to do.
Hard stop.
So in rabbitmq's management portal, we're going to go ahead and we're going to create the exchange first.
It doesn't really matter. I'll do
so under the exchange tab,
/application.
we're going to add a new exchange.
Yeah.
And we're going to name this exchange messages. And that's it. We don't need to worry about any of those other things. By default, they're good. And so now we're going to look down here and we see messages exchange has been created. Really simple. You've created a point in rabbitmq that allows rabbitmq to receive events that are sent to messages. Now we're going to go ahead and create the queue and the bindings and bind the queue to the exchange. So in the rabbitmq management UI, again, under the queues tab, we're going to add a new queue and we're going to call this new messages.
Really simple. It's going to be application.
You can set a TTL on this. This means that if after X number of seconds or milliseconds the message hasn't been picked up, it will be deleted from the queue. So we've gone ahead and created the queue. And now we're going to bind from the exchange messages on the message.new routing key. And we see the binding right there under the binding section. And so messages is now bound to new the messages exchange. And the queue, new messages, is linked up under the message.new routing key. Is everyone clear on that so far? If you have any questions, go ahead and ask. All right. So we've created everything we needed to use rabbitmq, to use the publishing, to have the publisher, to have the consumers created. We've created everything in rabbitmq that we need to. So what can we do with this? What can we really do with this? We understand now the basic core concepts of rabbitmq. So now we're going to put this together with PHP and start to talk about actual application architecture. So I just want to take another second. Is everyone absolutely clear? They know what publishers are, they know what queues are, they know what consumers are, they know what bindings are, they know what routing keys are. All right. All right, cool. All right. So I don't know about you, but I didn't really like to type out all that basic publish stuff. The AMQP lib is made for AMQP, which is a protocol that RabbitMQ supports. RabbitMQ supports AMQP. It supports Stomp. It supports, I believe, MQTT. There might be other ones. I don't know. Primarily, you're going to be using AMQP to communicate with Rabbit. You might use Stomp, but primarily AMQP. So the problem with that library is that it's very verbose, and I don't like anything very verbose or they're making me do a lot of work. So for the examples, I built something called Carrot, and it is accessible on the web. It's purely just for this sort of talk, but it's made to make things a lot easier interfacing with RabbitMQ. However, you can check it out. I highly suggest that if you are going to be using some sort of publishing system, that you make it as easy as possible for people to use that publishing system, to make it as easy as possible for them to publish events from your application to RabbitMQ, or to whatever you end up using. Because if you make it complex, if you make it highly verbose, then people are generally not going to use it. And let me tell you, once you start using RabbitMQ, you're going to find all sorts of uses for this thing. So what we're going to do is we're going to publish events from a web page. We are going to publish those events, and they're going to be received by multiple consumers. We're going to see how we can use the management UI to publish events, and this will help us test, do simple tests for our consumers. We're also going to talk about consumers self-publishing, so they're going to publish to other consumers. I made a mention of Caret, so if you want to look at Caret, Caret's available right there at GitHub, Jason Lotito, Caret. This is in honor of one of my colleagues who's a big My Little Pony fan. So we're not going to mock him or anything. All right, so Caret consumer code. So this is really easy. I try to keep it really easy. So use Caret consumer. We're simply going to listen to a certain queue, and the handler is this function right here. So in this case, we're listening to new messages queue, and the handler, it's going to echo out the message, just like we did before, but it's really simple. So we just take the new consumer, listen to queue, handler, listen and wait. The listen and wait is important because what that's going to do is it's actually not going to die off right away. It's going to sit there and listen to what is happening, and then when it receives a message, it's going to stay alive. The publisher in Caret code, using Caret, is very simple as well. Again, we're taking the array, or we're taking the arguments that are passed in via the command line, we're creating the message from them, and we're simply publishing it to the messages exchange, and we're publishing it using the message.new routing key, and here's the message itself. And again, just to see this in action, again, the same thing that we did before, we're going to go ahead and run the receiver, and we're going to run the sender. And again, that all works. And again, the key takeaway here is you want to make publishing as easy as possible. You want to make consuming as easy as possible. And to see examples of how that can be done, you can do it. You can look up right here. So let's get into the web. Let's actually look at a website and how to incorporate actually having data from a user on a web page sent to rabbitmq, and let's see that whole flow. So here's our publisher. This is going to be the part on a web page that accepts a post request. And we're going to see what that looks like in a second. But we set up the publisher right here. We're going to set it up so it publishes to the messages exchange. We're receiving a simulated message count because we'd like to be able to send over more than one message, so we get the send count right there. And then we're either taking the simulated message count passed in, or we're just using numerical 1. We're setting it to 1 by default. And then we're going to loop through and send the messages multiple times. The key thing to note here is that we can simulate work being done locally, and we can also just simply send it out. The one thing I want to point out is we're using eventually publish here and publish. So the difference between eventually publish and publish is that eventually publish sort of queues up the publish event to happen eventually, before the request dies off. It will eventually publish this out to rabbitmq. This queues up all the publish events that you might make, and then it will send it all at once. Whereas publish will actually publish it right away to rabbitmq. So you do have those options when you're publishing. If you have something that happens on your web page and you might have multiple events that occur, you might want to send multiple publishes. Maybe for performance reason, you might want to use eventually publish over publish. But by and far, I would stick to publish. But I did want to point that out. That is an option when using rabbitmq and when using this library. So let's use this written code and let's use the written Caret consumer code. So what we're going to do is now we're going to change the publisher. We're going to use this code right here to publish to the same consumer that we've already written. So we're not changing the consumer, we're changing the publisher. So the PHP code sits behind this form right here, and this is the existing consumer that we already have. And so what you're going to see is we're going to send this text message, we're going to simulate the message count, and we might do the eventually publish depending on what example this is. But I just want to show you right here. We're going to bring up the simulated message count to 4, we're going to send message, and it sends it off. And so we sent 4 messages to rabbitmq. Now we're going to simulate the publishing. It's going to process it 4 times. It's going to wait 2 seconds, or it's going to wait half a second in between, so it waits a total of 2 seconds, and then it publishes them all at once. The first time we published them as it came in. So, eventually publishing and finally publishing, what you need to do there is it works off of registering a shutdown handler. So you sit there and you can build messages, and then you simply say you simply set batch basic publishing, and then you set this right here, this whole thing right here, and then you need to register the shutdown handler. And the registering of the shutdown handler does this right here. It registers this. So you see, registers finally publish. So when we shut down, we're going to do the batch publish. We're going to do get channel and publish batch. And this is something that we have to do manually. Now, the AMQP lib will allow us to use this via the batch basic publish, but we still need to explicitly call this. And the reason for this is that we might not eventually want to publish these in the first place. So this is also good if you have a bunch of events that you might want to roll back. So thinking in terms of like transactional stuff. You send out a whole bunch of events, but let's say you get down the line, you're like, oh, wait a minute, we don't actually want to do this. There's some problem. So you never actually publish the batch. And so then you don't actually have to send all those events out. So let's do something else. Let's publish from the web, but let's add another consumer without changing any existing code. So here's the really cool thing. This is the thing that we start to see the potential. Who here likes working in legacy code? Nobody, nobody. Who here enjoys working in fresh, greenfield, we're gonna get it right this time code? If you come on, be honest. RabbitMQ and consumers are going to allow you to do that more often than not, because all you have to do is write the publish event, go into the legacy code, add that one publish event, and then anything else you want to add on afterwards, you can write as a consumer. So you can be like, yeah, I'll do that. Not a problem. Who here has registration code that is so old and ugly and deformed that they just hate looking at it? I know I do. Just imagine having a simple publish event that says member.registered. Now anything else that has to happen after a member has been registered, you never have to go back to that legacy code. You just write a new consumer. And consumers are small. They do one thing. They do one thing well, and that's it. You write it once and you're done. So we're going to add another consumer. We're not going to change the publishing code. So the publishing code on the web is not going to change at all. We're not going to change the other consumer that we wrote, the one that just simply outputs it to the command line. We are simply going to add another consumer, and it's going to add additional functionality to our application. And these are all contrived examples too, so don't expect to actually do anything. But in this case, we're going to be using Nextmo. A friend of mine works for them. This is why I use them as an example. But they do SMS messaging and sort of a lot of phone stuff and whatnot. So we're going to basically, what we're going to do is we're going to take the message and we're going to use their API, right? And we're going to send a text message whenever a message is inputted on the web, okay? And we're going to, this is all a bunch of the code just to get the messaging right and outputting it to Nextmo. But this is the consumer. So all this does is whenever it receives a message.new message or event from the messages exchange, it's going to set this up. It's going to run all this. Now, I want to make sure I point this out. We're not manually doing anything right here. This is setting the binding between messages for Nextmo queue and the messages exchange. It's building the binding directly in the code, and that's something that you can do with RabbitMQ, is when you connect to it, the consumer can create the bindings. And that's really nice because if you have a RabbitMQ failure, you simply restart the consumers and they recreate all the bindings. They recreate all the queues. So it's really handy if you want to automatically do that. So, what else do we do here? Right here, we return the message result and make sure that the message result status equals 0. We want to see whether that's whether it's successful or not. Because what you can do here is if it's not successful, if for some reason sending it out to Nexmo fails, right? If we don't get the proper status code, then we could requeue the message and try this again. So we simply return a false and say requeue this message. So this is what our messages exchange is going to look like. Once it's linked up, it's going to have a messages for Nexmo queue, and there's going to be a message.new routing key. And so we're going to go ahead, and we also see that we still have the new messages queue with the message.new routing key. So we have two queues, one publisher we've already written, one consumer we've already written, and so we're adding in a new consumer. And so that means we need to see all this. So we have the website right here. Same code as before. And I believe on top we have the, well, we'll see what we have on top. On top we have the old consumer. Yep, the old received consumer. This is the one that just echoes. And on the bottom we have the new one we just built, Nexmo. And so now it's listening to that queue right there. And so we're going to send the message out. And again, same existing code base that we're already using. We haven't changed anything, but we're adding additional functionality into it. And now you can see the queues each got the message, and each consumer got the message, and they were able to do something. We didn't add any code to anything legacy. We simply added code on top and listened to the same event. Question?
One, is there any limitation on encoding the message? And two, is there any effect limitation on the size?
So, the encoding, no. It does have a content type property or header. I think it's header. There's a content type header or property. They have, so messages in AMQP and rabbitmq have something called headers and properties. I forget which one has the content type, but there is a content type, and you can set that to be whatever encoding you want it to be, to say this is this. So generally, if I'm going to send stuff over, by and large, I use JSON. So my content type is going to be application JSON. And so that means anything reading that knows that it's application JSON and can then decode it appropriately. As far as the size of the messages go, nothing that's limited by rabbitmq itself. However, like anything, you want to make sure you only send over the data that you need. You don't want to be just sending over large amounts of data just for the sake of sending over large amounts of data. There's still network traffic that you have to consider. And then if you start talking about rabbitmq clusters, the issue there is that if you end up, the way clustering works, you can send to any of the nodes in the cluster. But if it needs to be passed on, let's say you have a queue listening on node 4, and you're publishing to node 4, and a queue gets added to node 1 that's also listening to that exchange on node 4, it then needs to route that data across the network internally. And while it doesn't sound like a big deal, it can start to become a bottleneck. So you want to be careful about the size of your data. Just as long as you're not making like huge, like 10, 20, 30 megabyte messages and stuff like that. But as far as for most purposes, I would say treat it almost like sending over individual objects of data. Whatever makes sense for your event itself. Does that answer your question? Okay. I know a lot of my answers seem to be sort of, it depends. So let's add another layer, because I absolutely love adding stuff to consumers. So instead of this time doing it from the web, let's add something to the consumer itself. Let's take a consumer and make that publish, right? Because that's always fun. So what we want to do is we want to send an email after the text message has been sent. So let's say we're using Nexmo, and now we want to also send an email out, right? Because we want to make sure that these people read our messages. So we're going to send an email, and we're going to send a text message, and then we're going to send an email. So what we're going to do now is we're going to create a new exchange. Now, why are we creating a new exchange? We already have an exchange. We have messages, right? An exchange is the event holder. It sort of accepts events. And when in our SMS code, in our Nexmo code, that is creating a new event. An SMS message has been sent. All right? So what we want to do is look at we want to create an exchange that represents that. An exchange called SMS. And that exchange is for saying, hey, we've sent a new SMS message. So in our consumer, we can publish to that exchange and it be accurately represented by the name SMS. So we're going to send this text message. This is the existing code right here. We're going to insert new code right down here. So I'm going to show you this section. Imagine that there's all that existing code. This is the new code that we're adding in right here. So we're taking the message result status equal 1. We're saying, is it successful? Right? If it's successful, we then want to send a SMS sent publish method. Right? So if it's successful, we're going to publish. We're going to publish this to SMS sent routing key, and we're going to send this along as a message and a message comment right here. So we're sending along the same thing. We're sending along this array right here, and then we're returning successful as we originally did. Just to note up here as well that we're setting up a publisher to the SMS exchange as well. Does everyone understand that? Anyone confused? All right, good. So let's write the email consumer. So that's all we did. So that's all we had to do to get this email consumer to work with our legacy web code base. So here we're going to have our email consumer. We're going to write the email consumer. In this case, we're binding to send email queue. We're listening to both the emails exchange and the SMS exchange. All right, we don't have an emails exchange yet, but maybe we did, and maybe we have this email consumer. This email consumer just sends messages, so we can send. So if we get an SMS event that's sent, we want to go ahead and operate on that. If we get something sent to the emails exchange, we want to be able to accept that as well. So this one consumer can handle things from multiple exchanges. And what it's going to do is it's going to listen to the send email queue, and it's going to decode the message, and it's going to mail that message to me. It's really boring. And then we're just going to say that we sent it out. All right, and we talked about all that. All right, so in this case, the email and the SMS exchanges are set up. The consumer is going to bind both of them together, and we'll see that live. And then we'll send messages through both of the exchanges. And we'll see this done through the rabbitmq management UI. This is the easy way to test your consumers without having to create publishers. You can easily set up consumers and mimic sending these messages through the rabbitmq UI. So here we're starting up the rabbitmq server. I don't know why I did that there, but whatever. So over here, we're going to go ahead and show you that SMS is set up. It has no bindings. And we're going to run send email. And now it's saying it's listening to send email, and we're going to refresh this page. Come on, refresh this page. And now the binding has been set up right there, because this has set up the binding for us. And so both emails and SMS now have the binding set up that we needed to have them set up. Now what we're going to do is we're in the emails exchange. Oh, we're going to show queues, I guess. Past me is really not doing this efficiently. Okay, we see this queue, the send email queue is now bound to both emails and SMS exchanges. All right, so now we're going to go ahead and we're going to publish a message through the rabbitmq UI. We're going to set the routing key to sms.sent, and we're going to set our payload to be whatever payload we want it to be. So the message, it's expecting a message, and we're going to send hello world. And we're going to print that. We're going to publish that. And you'll see it's processed up here. And so we've been able to send this to this exchange right here. And it's been able to publish over to this queue and then this consumer right here. This is me, I think. Oh, this is the scroll wheel, because I held it over there. So keep in mind, we can do, it was looking for anything. It was looking for star.send. So anything.send, so we're sending that as the routing key right here. And we're going to send over the message. So anything that's sent to this exchange that ends in .send is going to be sent to this consumer right here. And just to prove that, there we go, another message sent, hello world. Is everyone clear on what happened?
And we'll do that.
All right, cool. So let's see this all together now. Let's see this whole thing working together.
Yeah, that's good.
So, website right here. We have the original receive consumer over here, the next most start consumer that we added there, and then the send email consumer that we're going to have right there. So we've never updated this publisher. This publisher is still the same publisher we wrote at the beginning. We haven't touched it once, and it's going to power all of this. So again, we're going to run everything. And we're going to send this message, and you can see each of the consumers got the messages that they were expecting to get. So we've been able to add functionality, or simulate adding functionality to our application without ever having to go update the original code, just by adding in a proper publishing event. Everyone clear so far? Everyone confused by anything? All right, cool. So let's talk a little bit about application design with message brokers in mind.
Relevant.
So we want to talk a little bit about how to use virtual hosts. We want to talk about how to use exchanges, how to use routing keys. We want to talk about naming conventions, how to properly handle messages, and handling failure as well. This I had trouble with because I never fail, just like all of you, but we have to learn. How to use virtual hosts. Treat virtual hosts like you would any sort of permissions level system or ACL. Okay? Virtual hosts exist inside of Rabbit. We really didn't cover it too much, but when you get to rabbitmq, there'll be something called virtual hosts that you have access to. And it's simply permissions at its core. It allows you to separate your data. And so you can think of it also as data partitions. You can think of them like a database, if you will. You can have multiple exchanges inside of a virtual host. It's not a problem. You can have multiple queues inside of a virtual host. It's not a problem. Just think of virtual hosts as sort of that partition between data at a permission level. How to use exchanges. Consider exchanges to be the subjects of events. Okay? These are the nouns, if you will. These are what is being acted on. So members is an exchange. Messages is an exchange. Purchases is an exchange. These are all exchanges that you can create. Exchanges are, what publishers publish to. So they should relate to what is publishing to them. They should not be named for the queue they intends to consume them. It seems sort of obvious when I say it, but you'd be surprised at the number of times that I read exchanges that are directly related to the queue that consumes them. And then suddenly it's not necessarily, the exchange doesn't necessarily give you any information as to what's actually being published to it. It's not as concise. It's not as informative.
Documentation, so I know other developers right now.
How to use routing keys? Routing keys.
Don't trust it. I always go to
Routing keys are sort of the events. So in the exchange message, you might have a routing key message.sent. Routing keys should be verbs. They could be namespace, but you know that when you get a routing key message.sent, what it is. It's a message that's been sent. They should describe events on what the exchange describes. So the event here sent is describing what happened to the message, which is what the exchange describes. And this really gets into naming conventions. For example, the naming conventions of the exchange should be based around a noun. It should describe what is being sent through. I generally recommend it be plural. So for example, you'll have messages, emails, and members. You'll note that throughout my slide, I've been using different variations of that. Don't do that. But it should generally be plural. Messages, emails, members. Sort of like databases have these. You sort of have a members database. People generally choose members database. Maybe you choose member database. I don't know. But I generally recommend having this be the convention that you follow. This makes it easy to understand exactly what you're looking at. Routing key convention, naming convention, again, to make it as simple as possible, noun.event. You want a namespace with what the event is acting on. So in our cases, it would be, it was message.new. It's really easy to come up with all sorts of like underscore this and coming up with these crazy routing key names. Keep it simple. Keep it as simple as possible. Keep it as simple as possible. Make it singular. So again, message.new, email.sent, member.register. Avoid, I've seen this happen. Avoid being consistent just for consistency's sake. Just because you've decided that new is good does not mean you for messages, a new message, doesn't mean you should use it for members. Maybe you do, but member.new doesn't make sense to me. You know, member registered is better. Member message.new doesn't sound that great. Message sent probably better. But you want to make sure that the naming convention makes sense in the context. Another one that I've seen pop up is events should be honest. They should actually describe what actually happened. So don't send a message.sent or a member.registered event if that member hasn't actually finished registering yet. That event should be definitive. It say this happened. Now you could have something that says member pre-registered event. That's fine. But make sure your event is clear. Your naming convention is clear. Your routing key is clear. So member.registered, member.new. They shouldn't be the same thing, right? You don't send multiple messages for the same event. At MeetMe, for a period of time, for some reason, people were adding registration events. And when we finally looked at it, the registration events, there were 3 registration events for registration. 3. There was no reason for that. So additional things for routing keys, be specific. So if you're posting new, if your post is new, maybe post new link if it's a link type post, and then post new versus post new video. Maybe this makes more sense if you have different types of posts. So because remember, the consumers can bind on both of these types just as easily, whether it's post.new or post.new link and post.new video. Binding keys. They don't have names, so we don't have to worry about naming them. However, just be careful when you're binding things, the difference between post.new and post.new.ash, that you understand what you're going to be getting from the upstream exchange. Just like we said before, if you're not expecting later on post.new.videos, if that's something that you can't handle, just be aware of that. It's just something to keep in mind. Queues naming convention. It should really describe what the queue does. It should not be based on the event it's binding to. So just because a message was sent does not mean your queue name needs to be messages sent queue. It doesn't really help. All right? If you're binding to messages sent, it should be based upon what the queue is going to do, and it just happens to be reading messages sent. So for example, there we go. So for example, members and the routing key member.registered, maybe the queue will be named send email. Treat publish messages as a public API. So when you're sending messages, so as a publisher, you create this message and you're sending over this message each time. So in our example, we were sending over the message, and the first key in that message was message. This is a really bad naming convention for this talk, message and message, but hopefully you keep up to me with that. You understand what I'm talking about. So you should be okay with adding to that data, but you should make it difficult to remove data. This is a public API, a public data set, a public data format, data structure that you are committing to. So all the consumers are expecting that certain data is there. When you remove data from a message, consumers that depended on it will no longer work, and you have to update those. So be okay with adding data, but be very careful about removing data. Add data that you have available that pertains to the message. So if you have data that you've fetched, don't feel afraid to add that to the message that gets published to RabbitMQ, especially if it pertains. You shouldn't have to sit there in the consumer and go fetch data that the publisher had access to originally. If you're doing that, it probably is data that you can send over when publishing to RabbitMQ. And from the consumer side of things, you want to make sure you do this. Validate the input. Consumers should definitely validate the input because anybody that has access to RabbitMQ can publish to that exchange, and they don't need to share that same data structure. So you should really validate the input. No, really, do it because I've seen bad things happen when people don't. They simply take whatever's passed in as the message and pipe it directly into SQL, and bad things happen. Just because it's coming through an internal system does not mean you can trust it, all right? Your consumer should know when to drop messages that don't match what it's expecting. It should definitely validate that input. In addition to that, it should ignore extra data. So if a consumer gets extra data that it doesn't expect, ignore it. Another consumer might be expecting that data. Don't care. You're worried about the data that you care about that's being published with the message. Also, I've seen this pop up. People log messages out. People will take the message that comes in and logs that message that comes in. Be careful. Just be wary about that. We've never had this problem, but it's just something to be aware of. You don't want to sit there and log a message that's being sent through RabbitMQ and then have that contain private data. Logging in general is very dangerous when you're dealing with private data, or data privacy. Oh, and by the way, validate input. Handling failure. So, because you're used to writing PHP, you don't think of long-running processes, but our consumers are going to be long-running. They're going to be running for days, weeks, months. So check for memory leaks. Check to make sure that your application, your consumer, isn't leaking memory somewhere. Check to make sure that the code you're calling isn't leaking memory somewhere. PHP has some pretty nasty memory leaks in certain areas. Debug backtrace has one. It's just if you keep calling debug backtrace, it's going to continue to leak memory, and it's going to continue to consume memory, and there's nothing you can do about it. At least nothing that I've found so far. If you get one bad message, in your consumer, just ack it and move on. Be like, hey, this is bad data. I can't process this. No one can process this. Why am I getting this? OK, I'll just ignore it and move on. But if you get many bad messages in a row, maybe there's a problem. I'm of the opinion that if you get many bad messages in a row, you should probably die. The consumer should just die itself out. Like, I'm getting a lot of messages I shouldn't be getting. Something seriously wrong. So I should probably just die. It's a long-running process, so you have to be able to handle database disconnects, Redis disconnects, things of that nature, third-party refailures. So account for those issues. And then finally, I like to refer to this, default to die, don't process failure. So if at the end of all this stuff, something's going wrong and your consumer can't handle it, die. Have an alert system in place to alert you that this consumer is dead, but just kill the consumer off. Don't process failure. RabbitMQ will store the messages, it's fine. You can find out more information about RabbitMQ at rabbitmq.org. There's also a book I'll recommend, RabbitMQ in Action. Alvaro is the guy actually behind the PHP AMQP lib. This is an excellent book. I'm also going to recommend this book, The Practice of Cloud System Administration. This actually came out recently in September. I highly recommend this book. This book came out, and I was looking at my talk, and I was going, well, I should just have them read this book, because a lot of what I'm talking about is in this book. It's amazing. It's a wonderful, wonderful book. So I highly recommend this. That is all. It is 12:30 on the dot. I don't know how I did this. I'd like to thank you all for coming here. I hope you learned something. If you have any questions, please don't hesitate to ask. And remember, review all your speakers this week. Thank you very much.